Good morning. Welcome to Thursday of the conference day. One more day to go. We're almost there. We hope everyone enjoyed the events yesterday, the pyramid and dinner at La Gruta. We had a fabulous time. If you didn't join us, you missed a nice evening and a hot pyramid visit. So just a reminder that tonight is the 10th anniversary annual Dataverse community meeting. If anyone has not signed up to attend but would like to attend, just see me any point during today. I believe those events start at 7 p.m. in the in Ricon, that one, that place. So we look forward to seeing everyone. We're going to have some Dataverse trivia with some prizes, and we have some other surprises. So again, if you haven't signed up, you have a little red sticker on your badge, but if you still want to go, just let us. Okay. At 1 o'clock today, we're going to do a group photo by the flags where everybody took buses yesterday. So it's the only building with all the flags. We're going to do a group photo. And that's how we're going to take attendance for this community meeting. So you have to be in the photo. So 1 o'clock for that. Lunch is at 12. And let us not forget, at 5 p.m. before the social event at 7, it's the Dataverse Cup. We always have a football game, well, soccer where we come from, football game. So, bring your sneakers, bring your clothes, and most of all, be on the opposite team of Gustavo. Where's Gustavo? Is he here today? Where's Gustavo? Training. Okay, he might be training, he might not be feeling well, but whatever team you see Gustavo on, join the other team. Because we take a count at the end of the night to see who won, okay? All right, so 5 p.m. football game, 7 p.m. anniversary, 1 p.m. group photo in front of the flags in the main building. All right. We got a couple of minutes. Does anyone have any questions about today? Great, no problem. All right. I still hear people outside. Can we close the door and get people inside? Yeah, one person is all we need. Close it and lock it. No. So this morning we did start with 2 hybrid working groups meetings, the containerization working group and the Pi Dataverse working group. Those meetings took place this morning with both Zoom access and on-site access. Today we're going to start with a talk on AI and Dataverse by Stefano Iacas. I'm practicing my pronunciation of everybody's names properly. We're going to have Everything Data AI-powered LLM demonstrator for knowledge graph and linked data by Slava Tikhanov. Where's Slava? Did I say it right? I didn't. Okay, close enough. We're also going to have a talk on pros and cons of decentralized identifiers, DIDs, in Dataverse. Yevs Rosenhoek. Okay, that will be you, Slava, as well. Okay. Today we have, and also what's been going on the past couple of days, is we've had a parallel agricultural data workshop that's been taking place, led by Dr. Snap and her team. So that's going on in parallel. We will have another session on using IGSN IDs and sample management, use case involving RSpace and Dataverse. We'll have a multilingual semantic search in Odyssey portal, this morning as well. We'll also have another talk on leveraging persistent identifiers for enhancing fairness and interoperable and Dataverse repositories. And then we'll have our QA panel discussion And then the lunch break, again, 1 o'clock for the photos, and then we'll continue our afternoon day, okay? So right now, we're gonna start by introducing Dr. Stefano Yakis to speak on AI and Dataverse.
Thank you, Sonia. This time you pronounce my last name almost correct?
2 years.
After 2 years, okay. So I'm here to present something around Dataverse, which has to do with the AI, not just by me, but also by other people. I try not to spoil Slava's work, because he has done a lot of work, a lot of interesting work, but I just want to mention that it's not only us, it's everyone or many people in the community. We're trying to do this. So at this point, at least at Harvard, we are here. So we use somehow AI, but AI is still not at the core of Harvard Dataverse. Of course, these two images have been AI generated. And you can see Apple in the Dataverse name here. It will not work anyway. Okay, let me start. So a few months ago, we released the Ask the Data chatbot. It's a simple chatbot. As I mentioned on the first day in the introduction. And I want to show how it works. So this is already in production, and everyone can install this in their own installation, because it's configured as an external previewer, external tool. And essentially, what it does is, whenever Dataverse sees tabular data, it's a pity that this is not working. Anyway, when it sees tabular data, the chatbot icon will pop up along with the options of previewing or downloading the file, as usual. Yeah, thank you. At present, this chatbot has no knowledge about the metadata of the data sets. It only looks at the tabular data. The laser, the pointer? Okay. So, this little icon here. Okay, so when you click on that button, the first question which is asked by default to the chatbot is, tell me, what is this data about? And so what this tool does, it looks at the content on the table, and it answers something like, this data is about latitude, longitude, and event information. Okay, I can read the column names. This is fine, but still poor. So this is not what we expect from AI. So we can go one step further and ask more interesting questions like, tell me the range of latitudes and longitudes which are with the highest number of events. So in this case, he's trying to find a bounding box which corresponds to my query. And then, this is still okay, but not so spectacular. The spectacular things comes when the LLM really kicks in. So when you ask, okay, map the range of latitudes and longitudes with the highest number of events to the name of the countries. Now, this information is not in the data. The chatbot does not see anything about the metadata, and still give me the answer that these events are mapped to Afghanistan, Iran, and Pakistan. And in fact, this is true. So how this happens? Because the LLM now essentially was trained outside of course, the world of Dataverse. And so he has knowledge about geographical reference or bounding box of these countries. So it's nice. And it seems that users have started using it and like it. So this is Brian Schaffner, who discovered it on his own data, and he put a question, and he found that the answer is correct. So this is interesting. So as the data is only 180 lines of Python code, half of them are comments, you see here. So this is the license, this is the comments, and the rest is essentially build the UI for this chatbot, meaning that the real part of the AI happens in these 3-4 lines here. So it's very easy to improve over what we have done or to personalize to your specific applications. It's created as an external tool, and I will explain a bit more in detail how it works, and it's almost plug and play. So you just need to upload the configuration file because everything happens outside of Dataverse. So you can check on the GitHub repository the source code. So the reason why I prepared this is because this is a very simple way to create any simple tool with a user interface that you can create on top of existing database infrastructure without asking for any code on our side. So you can do totally independently from us. It looks like it is integrated with Dataverse, and it still can be powerful. So you can add statistical analysis, visualizations, whatever. So how it works? What happens under the hood when we click on this button? So what happens is that the only information that the tool receives is the file identifier corresponding to the tabular data. So, and then the tool just goes to the internet, of course to Dataverse, try to download this data and feed this data into an SQL database. And from there, the magic of the LLM starts. Because in fact, what we are using is an agent. An agent is essentially a replacement for a human, which uses LLM to interact with the information you are asking for. So for example, here, the agent receives the query in natural language, and what it does, it tries to understand how to transform this into an SQL query for the data. And you can see the reasoning here. So there is a table name data. I should check its schema to understand the kind of data it contains. So it talks to itself. This is called chain of thoughts in the world of LLMs. It does something, and at the end, it gives you an answer, which is based on the information I got from the SQL query and transformed back into a natural language sentence. Okay, this is fine, but you can do much more. So the chain of thoughts becomes more interesting if you look on the background, if you ask, of course, more interesting questions like who smoke more, men or women? And then it answer, men smoke more than women, but the way it gets there is actually trying to understand that he has to find some data, some column names, let's say, for which he can apply some query, and he knows that he has to group by, and so forth. So in the end, this is the SQL answer, and it transforms these two numbers in some reasoning, and finally in the result, and so forth. So you can ask more complex questions. So you can add by which amount and in which cities, because there are cities in this dataset, and so he tries to iterate. And this is all happening on the background. And actually the answer is accurate in this case. So sometimes it fails to answer, and I think you have experienced this many times in using ChatGPT or similar tools, because in this case I ask, who is the oldest person between smokers and which age he or she has, because I want it to be gender neutral in my question, and then he understands that I want both the oldest people between men and females. Okay, it's okay. Sometimes it fails completely. It doesn't give you any answer, and it usually answers in two ways: I don't know, or with an error. Like the reasoning took too much, and at some point he stopped trying to self-correct. So what I highlight here is a self-correction that he's trying to understand from the error, from, say, the SQL query that he tried. So he tried to understand from the error how to get better. Oh, there is one more thing. Yesterday night I tried this. ¿Cuántas personas fuman en ese conjunto de datos? And he answered correctly in Spanish. And this comes out of the box, just because the LLM is trained in multi-language. Although the agent works in English, as you can see here, the first thing it does is recognize the language, transform it into English, and then from there the agent starts doing his job. And then if you look at the end, the answer is 16. So this is the output of the SQL query. And he says to himself, now I know the final answer. And he translates the answer into Spanish without me asking for anything. So it's very powerful when it works. And I try French. Philip, can you recognize? This is Norwegian, Japanese. But German doesn't work for some reason. So he understands that I'm asking something about smokers, but then if you can try yourself on this data set, and then the answer is, at the end, I don't know. So essentially, he doesn't know how to match the word smokers in German with what he sees in the table. So, and there is no way to fix this. So the point is that why I want to bring AI within the core of Harvard, because I want to control the LLM. In this case, we are using GPT 3.5. We can use, for example, Llama or other models for those who know about these models. And in this case, we can get better control of how to handle these cases. Okay. The other thing that we did, which is still not yet in production, is the semantic search via sentence embeddings. So this is essentially what any ChatGPT-like thing does to discover information from a set of documents. So let me give you an example. And you saw in my first presentation the results of the survey, people complaining about the quality of the search results. So for example, if you use this query, COVID cases in Italy, the first results you get is wrong, the second one is good, then this one is wrong as well, and so forth. So far, Solar is one of the best way to actually index and do search through keywords. And this is what we have implemented in Dataverse. But we want to get something better. So for example, if you ask for natural language questions like dataset about COVID cases in Italy, now you see only correct results. And this is done through this technique of embeddings. And again, I can ask this in Italian, and the result works again. For the same reason that the LLM is trained in multi-language. So in this case, we're not using ChatGPT. All of this happens locally. So the embeddings are created locally with the local model, which is trained in European languages, but we can train other models. And there are many models, so we don't need to spend money, let's say, to do this part of the job. Sonia, I'm sorry, I used one of your profile images.
I'll be happy to see that.
So when we were a couple of weeks ago in Taiwan, she came to me and she said, "Oh, I'm crazy about this query. I can never get the results right about this query on Dataverse." So the query is Colorado Adoption Project. So when Sonia approached happily the Dataverse search and start typing this query, has this face. When it sees the result, and this is AI generated, sorry, Sonia. This result is not the first, not the second, the fourth, it's this one. And if you can see the name of the data and the keywords, of course they match one-to-one. The reason why they don't appear as a first result, so the first match is adoption project, is because probably, that's my guess, Solar used some kind of alphabetic ordering. So if instead of asking adoption project, Colorado adoption project, I would have asked adoption Colorado project, so switching adoption in Colorado, probably this would have been the first result. This is not the way the user want to interact with any search engine. So let's see what happens if I do the same query, so like a keyword query using embeddings. In this case, this is the third result. is better. You see here there is a number, which is the distance between what I'm asking and what is this data about. But if I do a more natural query, like give me the Colorado adoption project data, then it comes first. Meaning that this way of interacting with as a search engine, of course, works better if you talk to him like you talk to ChatGPT essentially, and not like you are searching for keywords. It's a different way of interact. Which one is better? Of course, it depends on the use case, and of course, we can get the best of the two worlds by putting together the research results of both things. So one thing I wanted to show you that this number, which I cannot read, maybe someone can read, it should be something like 0.25, and here it was 0.35. So it's the same data, but it has a different distance from the query that I'm making, okay? So this is really related to the way this model works. So just one slide about what it is, this word embedding. So the famous example is the following. So you have some kind of algorithm which takes your words and transforms them to points in an algebraic space. So the famous example is the following. So you have a vector representing king, a vector representing man, woman, and if you take the algebraic sum of these three vectors, so you take king, you remove the gender, man, and you add the vector woman, you get another vector, which is actually the vector queen. Okay, so that's nice. This was published in the early 2000s. But then they discover, if you train the same model on internet and you ask this question, so doctor minus man plus woman, you get nurse. So meaning that the standard word-to-vec algorithm has no understanding of the contents of the sentence, and it just answers from what it saw from the training set. Eventually, on the internet, there are less women doctors than men doctors. Okay, so this is the gender inequality which is happening everywhere. So sentence embeddings are much smarter today, and the LLM implement the most complex thing through NLP rules. And so essentially what happens when you do search embedding, you file all your documents one-to-one to this machinery, which produces a vector, and then you have your query, which is again some text, and you have another vector, and then you measure the distance, like you measure the angle or other type of measure you can do in these spaces, and you see whether your concept is close to this other concept or not. And you have a ranking, and the ranking is just essentially the angle between each document and your query. This is why each document can have a different distance according to the query, so it's relative to the query. Anyway, that's it. So the semantic search requires the construction of the embedding space, and the space can be grown incrementally. So for Dataverse, we did it, and if you want to do it for your data, you have to redo the embedding space for your data. The nice thing will be to do this for all the all the Dataverse network. Again, it's a few lines of code. We are using an open model. We do not have external dependencies, so we can do it in many languages, for example. And at present, this version is built only on title, description, and author metadata. But we can use much more metadata, so each installation can decide to add more metadata if they think that kind of of interaction in the search engine is better. Okay, so as I said, the project is to integrate the embedding search with a standard Solr search so that we can have the best of both worlds, because in many cases, exact keyword matching is important, so we want to keep both. And for this, the team is working on something that Gustavo presented on the first day. So some layer between, say, the Solr and the result that Dataverse gets before visualization. So this embedding search should stay at this level. And at that point, you can plug any search engine. You can even plug Google or whatever, so that you can get whatever you want, essentially, without changing anything on your installation. The other thing we are trying to do is fine-tuning OpenLLM on Dataverse metadata. So last time, I think it was on Tuesday when we discussed about data. So data is a very important resource. There is a lot of value in data, but metadata is even more valuable. Because if you don't have the metadata, you don't get the data. You don't get to the data. And so the lucky news is that Dataverse has a lot of curated metadata, and it's very good for training such models, which otherwise are trained on the internet. Plenty of crap, you know. And so other people are working on the same idea. They already implemented something by using GPT. So for example, Turbo Curator by ICPSR does something like this. So we want to add statistical analysis, as I said, and I want to go to the point where we have knowledge graphs of all data sets and metadata, and Slava work is mostly about this. So he's a pioneer in this. So that my idea is that one day, rather than having a search engine where you type a query, you visualize a graph, you start clicking on a graph, and you follow a path, and you can see from your data to which other data you can go by some graphical tool. And this is possible through the knowledge graph, so even across domain. Anyway, so just a couple of slides on the Turbo Curator for those who didn't see the announcement, I think a couple of weeks ago. So Turbo Curator appears here as an external tool again, and helps you to suggest you, say, recommendation for keywords, title, and the description of your data. So you start typing something, then relying on the knowledge of ICPSR best practices and ChatGPT. So this is the curation qualitative part, which is very important. In this process, you get suggestion. And gives you also information of why this tool is suggesting this or that. Okay, so you can see in this case, it added the United States because it discovered in the data that this is what the data are about. The other thing, just one slide, which I think is very important. There are a couple of works that Slava is doing. So one is the construction of the knowledge graph from metadata. And I'm not going to spoil him, but essentially you can use this in two ways. To actually using an LLM to create this graph, and using this graph to do semantic enrichment for your metadata in multiple languages and so forth. So that's all. Thank you so much.
Thank you. So we will have a Q&A session, and I know we have a lot of questions online. So we'll gather those at the end of all of the morning presentations.
So you're not taking questions now?
Well, you're leaving, huh? Please go ahead then, just for your presentation, because they have to leave.
Okay, so I guess if there are any questions, you're saying.
For your team, yes.
If our team has questions for the speaker. Okay.
All right.
Thank you very much.
Thank you.
So the SAS, the workshop folks, we're going to go to the SAS power.
Okay, so now we have Slava Tikhonov. Slava is going to be talking about everything data. AI-powered LLM demonstrator for knowledge graphs and linked data. Yes. They'll get it up for you, and here's your pointer to move your slides.
Okay, great.
Yeah, thank you. Okay, my name is Slava. I'm from Dansk, and I work as a senior research development engineer, and I'm going to tell you very exciting development that we have in our country. And also now it's getting international, so there's development in France and in Ukraine, and basically a lot of countries is getting involved in this. So before I will start, we do this work in Odyssey project, and Odyssey is Dutch National Infrastructure for Social Sciences, and it has a lot of ambitions, like, for example, to build semantic search based on knowledge graph. And if you're interested, we already have Odyssey portal with semantic search, and I have my third presentation today actually about this portal. So before I will start to tell you about knowledge graph, I want also to take attention to transformance paper, and this is from where it's all started. It's paper authored by Google, and I don't want to go in deep details, but what you need to understand here is a very important concept of attention. So attention is something that very critical for artificial intelligence, because if you'll see some sentence of words, you need to understand what kind of words can be considered as important and what kind of words can be actually removed from prompt. So my presentation is about this, and I'm going to tell you how I'm using knowledge graph to shift attention to different things. And this is why I'm getting different responses from large language models. And this is also very interesting. So it's called the theory of inventive problem solving, and it's basically like the way not to reinvent wheel. So according to this theory, which was created by a Soviet engineer in 1940s during Second World War, you can get only like 40 principles to do innovation. So it's pretty predefined, and you can combine different principles and you can get something completely new. And this is what I'm using on my daily basis, and this is also the way why Ukraine still resists against Russia in this war, because we are very inventive, we are trying to invent new things, and this is why it's getting so strong. So according to this theory, you can find a solution discovered by some other science already. So if you have some question and you don't know answer, probably someone else already found this question, this answer, and because it's described by different words and you have different terminology, you just don't know about that. So, and these are really like 40 principles is pretty predefined, and everything that created by humanity, you can just fall down in this, and in a way it can be considered as like first LM model ever created by humanity. So I started to think about how to apply those principles, and I found a similar approach in physics. So like LM, you can consider like compressed knowledge. It's really like you have statistics of all keywords and sentences, and you can predict frequency. So by using this approach, I started to apply concepts from physics. Like in this example, I'm trying to get fission to be done for LMs. So it's really like if you want something like atomic explosion, you are just using isotopes uranium and plutonium, and you are changing state. And instead of getting like stable system, you're getting unstable system, and it responds differently. So this is what I started to use also in these LMs, and it's getting unpredictable results sometimes, but still it's helping to get from artificial intelligence more accurate results. It's really amazing that if you really think to get answer on your question in more accurate way, you have to introduce randomness. It's contradictory to what we think, but it's really like helping us to get more clusters, more tensors created on our answer, and model can recognize better clusters and give better answer. So this is kind of a way to think about what I do. So what is everything data? It's a framework that I've created for Odyssey, and after some other projects started to reuse it. So we have a couple of European projects using the same framework. And it's API created on top of large language model. So I'm not using ChatGPT, it's too expensive and it's too closed. And I started to use Llama and some open source models like Mistral from France and some others. And basically, I'm getting all responses from LM and packaging back in knowledge graph. So it has a lot of extra functionality. For example, it can recognize semantics, but it can populate also data points from data sets. So it's also not only on metadata level, but now it works on data level. And it's a way, in a way, it's decompressing large language models into something that you can already query. And there is also connection to Dataverse, and it's also supporting linking of variables of semantic web from Wikidata and other control vocabularies. So it has a lot of useful functionality. So it's open source, so you can just, if you're interested, you can find it here. However, you need a really powerful cluster to run it with GPUs. It's impossible to get it deployed on normal computer, but it's working. So now I want to show you use cases. So this is very interesting use case, and this is something that we're doing for Netherlands. We have data providers delivering metadata in Dutch. And we want researchers to connect their data sets to other countries. So what we do actually, we're using keywords from this data set, which are in Dutch, and we're also using context. And context is defined by description or some other pieces of this data set. So we're sending to API that I've created keyword and context, and this model actually is able to recognize, in vector space, it's able to recognize right concept and get it translated into languages we're asking. So in this example, we're getting like 14 languages, and this is really the way how you can deal with multilinguality. So it doesn't matter if your data sets will be in Spanish or in Portuguese or in other language, still it will be linked to the same concept, and this is how you can get it in knowledge graph already linked. And in a way also, it's a way how you make decolonialization of data with using open data. This is what we heard yesterday. So I'm really excited about this use case, and we started to use it on a massive scale. We started to translate all our data sets, and we're getting also Chinese and other Asian languages. So it's really now like kind of mainstream in our project. And second case, we started also to populate control vocabularies with those terms. So we are getting from a large language model, we are getting all translations and original ontology in Dutch or in other language, and we are just enriching this ontology with all translations they are getting. And all this information, all these extra keywords are being integrated with data search. So that means that if you'll search, let's say, in Italian or in Chinese, you'll still be able to find metadata in Dutch. So it's really like multilinguality, and this is what you want to see, how you can get all this information from data search. So another use case. I thought it would be nice also to try to create ontology completely from scratch, not to enrich ontology, but just to use some extra source to fit inside of artificial intelligence, and after some time to get complete cosmos with all ontologies already published. So apparently it works. So now it's getting Wikipedia as an input, and in like half of an hour, it can get a description of everything. So it's recognizing all concepts, all important words. Now I'm also getting back to attention. So we're getting all these important words translated in languages, in other languages. And also we are producing a description automatically. So all this stuff is done by AI without human. And you can get ontology created for any topic in reasonable time. And usually, if you'll think about project that will do the same, probably it's like 2 or 3 years of work of 20 people, ontologies, and also they should know every language, so it will cost a lot of money. And now it's kind of available and everybody can use it. So next use case, coming back to Wikipedia as input. And why Wikipedia? Because this is also the source of a large language model. This is how Llama and ChatGPT and others that trained their model. They just ingested inside Wikipedia, and this is why all information published there is already available in the model. So it's kind of reliable. So we started to use this as a kind of graph miner. So there is knowledge graph, and this is really remarkable because I don't know if you can see it, but there is a sentence about COVID, like symptoms of COVID-19 are variable, but often include fever, cough, headache, and some other stuff. So you can see it's extracting facts. This is what language model does itself. And what is even more remarkable, it's also getting standard ontologies like OVS or SCOS recognized. So you can get all those relationships directly from LM without any efforts. And this is kind of the way how we are getting triples that we will store in knowledge graph and after we can query. So we can turn any content published somewhere in web, or even some papers, or even some documents, some manuals, we can turn in knowledge graph very quickly by using this. And now I'm coming to AI assistant. So Stefano just showed some examples, and we do quite the same. So we have the same use cases when people are coming to us and they're saying, well, we actually don't want LM to give us direct answer, accurate answer. We want LM to produce SQL. And I think it's kind of the same approach that we are going through SQL. So we are producing the SQL statements that people, analysts, which know everything about topic, they are able to run on their database, and this is kind of assistant. Next use case, I think also very important and very useful for researchers, because we're able to recognize a list of questions that can be answered by using specific data set. This is amazing. It's a kind of example on Titanic survival data set. So basically, a model is able to generate list of questions that can be directly connected with data set and can be found by a researcher. And this is very valuable information for any researcher looking for data. And we're also incorporating this information in knowledge graph. So where do we go from here? Probably you know that in Europe, Cosmos is a very popular platform to publish control vocabularies. And I really tried to get Cosmos done on European, Cosmos promoted on European level because it has a Jenna Fonseca triple store. So principles are very nice, and we can reuse this as a kind of component for querying data. So you can see also it has Sparkle endpoint, and this is a way how you can get access to data. So another example on data management topic. Here you see AI-generated graph, and yeah, I just need to show this. So here we have some standard ontologies like SCOS-related, SCOS and OVL, but model itself recognizes something unexpected. It's able also to find relationships. So all these relationships, we don't know from where it's coming. It just model itself, because of how it was created. It knows that we're getting these kind of relationships from it. And if we'll repeat the same query a lot of times, we'll get different relationships, but kind of similar to what we have here. So in a way, we can also create embeddings which will describe ontologies, like SCOS, but it will be AI-generated ontology. And I think this is really fascinating because we can use it for any kind of embeddings, buildings for any kind of science. So now I'm getting back to trees, to theory of inventive. We can find a lot of interesting solutions by using this approach, created by other sciences. So to make it even more interesting, we started to make summarization of available ontologies, and this is being used as input for LM as well. So LM is recognizing those ontologies and kind of putting in Sparkle query. So it can generate Sparkle query by itself, now knowing this information. And now I'm coming to the point to talk to data. So one of my friends, he used to work at Google, and like 4 years ago, he introduced me to all these LMs, and I was probably one of the first people on Earth testing kind of predecessor of ChatGPT. So he told me, you will see the real power of usage of large language models. You will see when you will be able to talk to data just like to your assistant. So how to talk to data? Stefano just showed some use cases, but I wanted just to take your attention to this kind of problem that if you query LM, it will know only historical facts. So if you'll train on something, it will know something. But if something that happened afterwards, after it was trained, it's not able to respond to you. So if you'll ask question, who was President of the United States, it will give you a response. And if you'll ask question, for example, who won Eurovision Song Contest in 2023, it will say, I know nothing because I was trained before. So to solve this kind of problem, I started to build kind of my own Google. And there is a platform deployed in France at the moment. It's called now Museum. It's collecting any kind of documents from web. It's getting all keywords and all metadata extracted automatically. It's published in a Dataverse. So I'm trying to actually enrich available source and to get more information available for large language models. And in some projects, we already started to, like NewsIT, this is a project funded by European Union, and we are also having the same for music. So we're collecting information about music. We're not keeping any screenshots, any full documents, it's just metadata inside. And this is how it's been registered, so you can see there is a title, description, and that's it, and keywords. So, assistant prompt will be slightly different in this case. I'm coming back to attention, and instead of asking direct question from LM, give me information who was winner of Eurovision Song Contest. I'm asking, can you provide me keywords to find this information? And this is what Knowledge Graph also does. So it's recognizing important words, and it will become part of prompt. And Sparkle query to find this information looks like that. So all available information is already in Knowledge Graph ingested from Dataverse, and it just goes here. Here's Eurovision winner 2023, and it's given result, and result is not being interpreted. In interpretation of a large language model. It just knows that Sweden won Eurovision. It's getting this from original source. And now we are coming to the point where we need the interpretation from LM as well. So if we'll feed this sequence from Dataverse into large language model, it will recognize all ontologies like Dublin core inside, and it will give right Sparkle. So we can already produce Sparkle automatically based on information that we have. And if we'll ask ChatGPT, it's also, because it trained on the same data, it knows how to create Sparkle. So thank you. So some questions before I will start with second? No?
Start your second one.
Okay.
Questions and then Q&A.
Can someone help me with second? Huh?
Is that oh, here it goes. No, you were there. You were there. They had it. The next talk.
Okay, so the next talk. So now we are coming to the point where we have a lot of artificially generated stuff. So like keywords being recognized and linked and... Yes, that's right. No. Oh, sorry. Oh, yeah.
It was
Yeah.
There you go.
Yeah.
Yes.
So if we run computations on LM, probably it will give us different results again and again. So we need to think about sustainable infrastructure. So here I want to propose to use decentralized identifiers, DID, in Dataverse and for control vocabularies, for any kind of artificially generated content, because we really need to think about sustainability and reusability and reproducibility in this case. So before I will start, I wanted to just take your attention to the point how I understand what Dataverse does. In fact, we are building an operating system for open science, and this operating system should be very flexible and should be robust enough to scale up to any topic. If there is new pandemic will come, we should be able to switch and use it immediately to find the right answers. And we need to build network services. We need to do a lot of things, and I think Dataverse will allow to do that in the near future. So why building fair decentralized data network is so important? Because we're Danes, we're Netherlands, and people in France, in Canada, so we are already distributed. And if we want, for example, to build semantic search, it will be distributed semantic search. However, now all metadata will be harvested in Harvard Dataverse, and those collections are available for search, but this is something else. This is really a knowledge graph, and knowledge graph created in every node by specific data provider, by specific university. So we need to think how we are going to make it sustainable, and we are going to deal with revisions of data sets and this kind of stuff. And what is even more interesting, now we started to work on life sciences, and Case had presentation. So we are thinking how to make how to use decentralized identifiers also for hospitals, for example. And there is also a possibility that you can create something like DOI, but it will be invisible for the public. And just using that some specific cryptographic key, you should be able to resolve it. So I just wanted to tell a few words about current costs. So if you think to use the same approach using centralized services like DataSite, it will be very costly. They're very good for keeping data sets and to keep in all provenance and all citations, but unfortunately for control vocabularies it will be costly. So we need to find some other principles like blockchain to store all this information. So there are typical problems of centralized identifiers. I think you recognize most of them, and there is a workshop that we had like a few days ago. And first of all, it's disambiguation and authorship. When two authors with the same name, without ORCID, for example, you don't know to whom you will link your data, right, or your paper. And it's very difficult to assign paper to a specific person without knowing that this is actually the author. So some people can also claim false authorship, and this is not okay. And centralized entity can be considered a single point of failure. So centralized control vocabularies, I already mentioned a few times, Cosmos. It's a great platform, I really like it, but it has a few problems. So for example, if you will think about ELSE Thesaurus, it's hosted by CESDA, but we're also in Odyssey, we're hosting our copy of ELSE. And as soon as they will update their copy of control vocabulary, it will be kind of different. And we don't know what was changed, what kind of concept became different. So this is where we need another solution for that. So decentralized identifiers is a possible solution, and here we have core features. Like first feature is permanent persistent identifier, something like DOI, but deployed in distributed manner. So it's like blockchain. And we have resolvable identifier. You can look at descriptive metadata as well. So we can also get JSON-LD from Dataverse and attach to this persistent identifier in the same way like DataSite does. And it's all cryptographically verified with private and public key. So it's really secure. And it's really decentralized. So, I mean, there is no centralized entity controlling this. So if you want to use this decentralized identifier, you will run a piece of infrastructure in your place. It will be connected to blockchain kind of network. After it will be synchronized. And I really believe it will be the best solution. As soon as we will get hundreds of Dataverses providing this as a standard feature. So there are also concerns about using decentralized identifiers. Not all use cases are actually suitable for DIDs, and it should be, you should think twice before you will go for it, because it will require a lot of expertise. Also, the cost of DID can increase if you'll start to put billions of identifiers. So we need to think about performance. And also DID takes away power from centralized authorities, because you're producing a private key for every identifier. And you should think about something like a digital wallet. And if you lose your digital wallet, you will lose access to your data. This is important. So the place of DID as unified resource is basically like URI, URL, and URN. It's the same. It has DID as a scheme, and there is also DID method and DID specific string. So I believe in near future, it will be also possible just to put DID in a browser, just like HTTP or HTTPS response, and it will be resolved to a specific page. So this is coming also. So there is example how DID looks like. It has, like I already said, private and public keys, and it's quite simple implementation. So you can see there is DID, this example, and with some hash code, and hash code is something that you can also resolve. So I already mentioned that Dataverse JSON-LD can be also placed in a DID document. So basically, this is a way how to really make dataset metadata really sustainable and persistent, because it will be stored in blockchain. It will be not possible even modifying in some cases. Probably it will be stored forever. And also, it's possible to use parameters, which is also convenient. So if you have some dataset stored in this kind of ledger, you can also request JSON-LD serialization or XML or DDI, whatever you want. But what I wanted to stress, decentralized technology is not the same as blockchain technology. In fact, blockchain parties are holder, issuer, and verifier, and DID is kind of also nesting this. But there are also implementations that allow to run the kind of local instance of that. So you don't need to run the whole blockchain, it's even not required. You can install a component, let's say at Harvard, it can be installed at Dansk, it can be installed in France, and after 3 nodes will be talking to each other, and that's basically enough to make it sustainable. I already mentioned you can also resolve, so there is resolve DID, so there is a universal resolver, and you can just put DID in there, and after you can get JSON-LD coming from Dataverse or from any other source. Also, it's very convenient. So in some implementations of DID, there is possibility to create kind of temporary access. So, for example, if some professor has a lecture and he has some protected data, he can allow people to access data for half of an hour, and after access will be distracted. So it's also very convenient. So the idea for control vocabularies, this is what I already showed you, that we are creating control vocabularies. We started to generate a lot of control vocabularies that should be more sustainable. So we are started to assign the idea identifier to every concept and attach all translations to this the idea identifier. And 2 years ago, I already tried to implement DID support. It's quite straightforward. And I'm really happy to hear that now we have support of a couple of few providers, and we can also consider like to add it next to DOI and handle support. Also, decentralized archiving is a very important feature that we are working on. So we can also archive content with S3 interface, and we can assign the idea on top. So in a way, it can bring sustainability to all data published in remote storages. So the idea itself is very nice implementation, and it's very generic and flexible, but it's not very adopted for science. So now we're working with a lab called Desky Labs in the United States, but actually they're distributed, and they're working on DPIDs. And this is implementation specific for science, and it uses the same principle. It's basically the idea but it has much more features, and it's based on blockchain also, and it's much more sustainable. So I really recommend you to take a look and to consider this in the future. And it has a lot of benefits, like it's open source and totally deployed in your place, and basically it's quite flexible and costs you zero money. It's just a component that you should deploy in your place, and after you'll get it. Okay, thank you. So, questions or no questions? Okay.
Because we had such a great discussion when we have these during the QA, and I'd like to maintain that. Plus, we have a lot of people online that are submitting questions, and we'll be able to see it as a group. So I know everybody's excited with the questions. Just hold them on a piece of paper until we can get there. Okay. So our next talk is using IGSN IDs in sample management, use cases involving RSpace and Dataverse. And I believe our speakers are Rory McNeil and Vida Plankett. And I'll give credit to the rest of your team, Norj and Rory Edmonds. Am I missing anybody? No. Oh, thank you. Arturo's going to do the intro, so here you go. All right.
I think it's going to be easier to use these ones. Okay. Hello, everyone. I think we have already met some of you. My name is Arturo Garduño Magaña. I am Regional Engagement Specialist for Latin America. And on behalf of my colleague Rory Edmonds, who is a Product Manager for IGSN at DataSite, it's a pleasure to be here with you. Thank you so much to Vida, to Rory for the invitation. And well, let's start. So the International Generic Sample Number is a persistent identifier that can be applied to any material sample coming from any research discipline. As well as individual samples, the IGSN IDs can also be assigned to aggregates, for example, that sometimes you may not want to have a PID for every object, but rather at the collection level, it can be really helpful. It also can work as a feature of interest, namely the collection site where the sampling activity was carried out. Also, we have sometimes when the samples are destroyed or discarded, these can be destroyed in an analytical process or discarded. The sample metadata should also provide information on the current state of the status of the sample. And it's worth noting that the IGSN IDs is also applied into the sample itself and not to, for example, a sample image or an analytical data. There are five main use cases for IGSN IDs, which are presented on screen. They also provide a digital presence for the physical objects. As mentioned before, the landing page displays a description of the material sample identified by the IGSN ID. And of course, it should include all the elements that improve discoverability, including domain-specific metadata. They support established sample workflows. And for example, to support the sample collection management, a material sample can also be linked with its digital representation through labeling. For machine-readable identification, the IGSN IDs can be encoded as QR codes or barcodes. To support sample process management, applying IGSN IDs in early means also that the samples can be tracked through their life cycle and as they move to other lab or repositories. It is important to note that it is possible to transform the locally unique identifiers that we already have into a more global unique IESN IDs, meaning that no changes are needed to establish working procedures and naming conventions or data systems, for example. It is also important to note, finally, that IESN IDs enable cross-linking and citation of the samples, and the IESN IDs metadata can be used to describe relationships between material sample and related datasets, publications, people, software, and all the elements that we have discussed before during the event, for the purposes of discovery and credit, of course. To connect IESN IDs to mirror, we can connect IESN IDs to mirror hierarchical relationships among the collection sites, samples, and subsamples. Through this partnership between DataSite and IESN, the IESN organization, the DataSite services can also register IESN IDs and make them available to all DataSite members and all the consortium organizations. And from a functional perspective, an IESN ID is basically a DOI. They are exactly the same. IESN IDs can be registered through DataSite's Fabrica interface and all the services, the APIs. And it is important also to note that for this talk, through the integrations provided by DataSite service providers, with RSpace being the first to support IESN IDs, as we saw yesterday. The IESN IDs are also encoded in the DataSite metadata schema, and all the IESN IDs have a DOI prefix and a customizable suffix, which means that, as we mentioned before, they are resolvable to a landing page. And also the IESN IDs can be found through our usual discovery services. So what's the difference between an IESN ID and a DOI? Basically, these are differentiated from DOIs at the repository level. And they must be registered in the DataSite repository account with the type IESN ID catalog repository, and the repository accounts must be used exclusively to register IESN IDs. Now, though there is no time today to go into details, we would like to finish by quickly mentioning a little bit about the IESN ID metadata. As we mentioned before, the IESN IDs are encoded using the DataSite metadata schema. However, for IESN IDs, the resource type is always physical object. So it is important to note that we have been working with the IESN organization to develop guidance and best practices for IESN IDs, and we are continuing to work to enhance and support the documentation, and of course to strengthen the bonds in terms of collaboration with different disciplinary samples communities. And thank you so much for your time. If you want to know a little bit more about IESN IDs, we invite you to contact us at info@datasite.org. And now I will hand it back to Vaida. Thank you.
Awesome, thanks Arturo, that was really useful, and please forgive me if while going really fast I say DataSite instead of Dataverse or the other way around at some point. Just correct that yourselves in your mind. Yeah. So I'm Vaida, I work for RSpace, and I want to talk to you about the integration we've built. So you've heard about RSpace already, a digital research platform for RDM, and so it's an ELN, a sample management system, and the main focus is integration on with existing tools so that you can still continue with your current workflows. You've already seen this graphic before, so I'll be focusing on a bit about DMP tool, a bit about field collection, and then obviously about our integration with Dataverse. And regarding RSpace, we'll be focusing on the sample management system, RSpace Inventory. So RSpace and DataSite collaborated together on a grant project that was focused on interoperability through PIDs and research platforms. And so we decided to really keep the scope pretty small. We want to research, design, and build a prototype to support one PID, which was IGSN IDs for material samples, in one research tool, a sample management system. to really try to understand what does the work of interoperability involve. And at first we thought, well, I mean, it's one PID in one research tool, right? Like, how hard can it be? And so, listened to hear about that. We took a user-centric design approach. So to design something that's useful and user-friendly, because we know that researchers don't want to spend extra time doing work, so trying to make it as easy as possible for them. And so for that, we needed to understand what were the real-life workflows. So for that, to be able to understand the IGSN use case requirements, and then to actually build a core use case and identify it to address it with a prototype implementation. So our two institutions that we talked to were UIT, the Arctic University of Norway. They deal with geological samples. They do field campaigns in remote areas, which means offline data collection is important. They want to assign IGSN IDs even sometimes before going to the field in terms of knowing the quantities of what they want to collect. And they want to push everything, various research records to Dataverse. We also have Rothamsted Research that does something slightly different. They do longitudinal agricultural experiments. So they have field samples and instruments rather than just kind of picking things from the field. They also have a focus on having a large gene bank that they want to increase the visibility of and actually start connecting all those resources together in a PID graph. So I think this quote kind of illustrates well the approach we've taken. So this is feedback from Norche, a senior research data manager at UIT. And she said, I know but most of this is bolded, and it's because it's a really good quote. So she said, we have to learn, like researchers have to learn to use another tool or platform or interface in order to, let's say, register a PID. And researchers find it difficult to relate to different tools, platforms, and interfaces for the different phases of their data management. It's useful when there's maybe just one entrance point, so they would not or hardly notice it that they move from one place to the other, just being able to do things and have them work. So the high-level workflow, I'll go into the separate elements afterwards, but we tried to conceptualize which tools we'd use as part of this workflow. And so for the project, we focused on how do we implement IGSN IDs into our space through integrating with DataSite, and then we also then wrote out and collaborated on the spec of how the other integrations would work, and so that's what we're working on now. So first, I'd like to go over the actual IGSN ID integration. So this is the sample inventory system we've got. So you can see you have samples, containers, you can have sample templates, you can then organize things as being on your bench as active work. You can import samples as CSV or export them as well into a different tool. You can do filtering of your results with different views, some visual kind of container views as well. And then on the right, you have the actual information about that item, whether it's a container or a sample or something else, with separate sections. So what we did is that we added a section called identifiers. So researchers can just click mint a new identifier, and that unrolls some metadata that we automatically pre-populate with what we know about the person and already the information entered about the sample, so that all the mandatory information for IGSNs is already there. So researchers can just start building and adding the kind of more relevant and interesting information. You can directly publish the identifier from inventory, and that gives you the GUI and the public link to access the landing page. And the landing page then just replicates all the information that you've provided to the system. We also added a nice little interactive map thing if you provide geolocation information, so that you can provide a point, a box, a polygon, or a textual reference, which is again based on the DataSite schema of how geolocations are defined, and it's interactive and everything, which is quite nice. And you can also, as mentioned, define complex geolocation shapes for farms, for example, so polygons. And another aspect is that while the IGSN ID schema is really useful as a kind of base common schema to query and find out about samples, we obviously can't index every single specific thing about a sample as part of the DataSite querying. So it makes sense for the landing page to include very custom domain-specific information about the sample that the user provides. So you have the option to select whether you want all the other information outside of the IGSN information to also be made public onto the landing page. So you don't actually need to enter information somewhere. You just take a checkbox and that automatically adds all those fields to the public landing page. This is just to note that it's pretty simple to set it up in terms of the system administrator filling in some API details, but the user doesn't ever need to see any of this. They don't need to know what's happening. They just can do the whole, registration, draft states, then making something findable, maybe retracting it, which I think is quite user-friendly. And we also recently integrated with the ROR identifier so that an RSpace system administrator can say, okay, we have a ROR for this RSpace instance. This RSpace instance is used by this organization, and automatically, whenever an IGSN ID is published, the ROR is passed as the creator's affiliation property, because that makes sense. So again, trying to link the bits together. I won't go into detail about the project outputs. We ended up talking quite a bit about the collaboration needed between different parties to achieve this kind of integration. So institutions, different roles within institutions, the service provider, both technical and products, and then data side, again, technical and products. And the main things to note here, you can access this and know the link for the details, but it was things like clarifying responsibilities. So for example, if researchers tell us, yeah, we don't know how detailed to make our schema or how to make it flexible enough, that's not something necessarily that we can resolve as a tool provider, but something that maybe DataCite or communities of practice can resolve. Developing a shared language as well. It was an embarrassing amount of time into the project that I finally realized that the landing pages needed to be developed and hosted by us. I just assumed, oh, well, DataCite does the PID stuff, so they must also do the landing page stuff. But then realizing, oh, wait, the landing pages are hosted by us because we can then customize them to our use cases. So it doesn't make sense for DataCite to host them. So that's covering the IGSN integration. So now we're kind of working towards the more vertical interoperability part. Oh, yes, good. So RSpace and FieldMark, that's the first part of this. So FieldMark is a field data collection tool with customizable data templates. So you can see why this was the tool we chose for the use cases we have. So it provides you with the ability to structure data fields and also create relationships. So for example, an observation is a child of a sample, and it has support for geolocation, so you can use it on a mobile device and automatically get the geolocation of an object. You can record images, observations, instruments. And the key thing that's really useful here is that it's usable offline and on mobile devices. So you're able to kind of collect samples using the template, and once you're back with internet connection, it syncs with the FieldMark server, and you have all that information now online. So that seemed perfect for this. So what we scoped out is that this was quite interesting because we started thinking, okay, well, in an ideal world, each component would be able to, communicate with the PID infrastructure and update the PIDs and so on, but that can become very complex very quickly. And what's nice with this flow is that we realized that FieldMark doesn't actually need to know what the PID is. So RSpace can register IGSNs ahead of the field trip. Then you can print a raffle book of your QR codes. You stick that onto your samples when you're in the field, and you scan them in, and FieldMark can just treat that as, oh, well, it's a field, it's called IGSN ID, it's a number, it doesn't need to communicate with DataCite. And once you record all your information, when you push that to RSpace, RSpace can identify that the IGSN ID field is not just any other number, but that it relates to the IGSN IDs you've minted previously, and it can then generate the samples and the sample templates based on the FieldMark templates, and make sure that the IGSN IDs are associated with these entries. So that's quite nice in that we do still have that IGSN ID permanence, and you can track, for example, if you haven't used a few of the IDs, if something's missing, but FieldMark itself doesn't need to have a back-end solution with DataCite. When it comes to Dataverse, we already have quite a bit of an integration, so I'll just go over that because it's relevant to how we want to improve it. So you can choose a variety of formats, including RO crates to export to Dataverse from RSpace. So you just select a bunch of documents on your workspace in RSpace, and you select the format, and then you can select to export to Dataverse, and then fill in some metadata that will then populate in Dataverse. We also support ORCID as part of that flow. So if the researcher has added an ORCID to their profile, that will then be passed in the Dataverse metadata as the ORCID of that export bundle. But there's also DMP tool. So if you're exporting a data bundle and you say, okay, I want to associate this export with a document that I've imported from DMP tool, then what happens, so this is a little bit complicated, the Dataverse export that you said that a DMP is associated with, the export ends up with a DOI. That DOI gets sent back to RSpace, which then sends it back to that DMP and DMP tool and says, this DMP has a data set associated with it, which is the Dataverse export. So making sure that when things go forward, they also go back to make sure everything's linked together. But that's not all. We also have control vocabularies. So you can tag inventory items or ELN items with vocabularies you've imported from in a standard format. You can also enforce that people have to use vocabularies to annotate their content. And then when you export a bunch of documents, and some of them have ontologies or vocabulary terms, these get passed through to Dataverse with the actual URIs from those schemas, so that there is, again, that nice reproducibility. And so when it comes to this flow, we're thinking, okay, how do we make it so that IGSN ID then flows forward into Dataverse? So from FieldMark, even before you go into the field, you register an IGSN ID. How do we make sure that it continues on until you export, let's say, related materials or some data sets regarding to the samples into Dataverse? So in RSpace, you can actually link experimental entries with the samples used. So essentially every single field in a document has a list of materials you can add to it, and that's essentially a list of samples or containers, and you can specify, I've used this quantity of a sample in this experiment to kind of keep track of that. And so we can use that when you're exporting data into Dataverse. If the documents you're exporting have samples attached to them, then we can pass through the IGSN IDs into Dataverse as related materials. So inside of Dataverse, first of all, the list of materials looks like this. So you can add several items. You can also automatically move them to your workbench, so inside of inventory. So it's both the LN and inventory are quite closely tied to enable workflows of working with samples. And so in Dataverse, we can actually populate the related material fields with those samples and their DOIs or IGSN IDs. Now you might notice here that it's all text, right? It's not nicely formatted as a link like the ORCID one. And so that's one improvement we want to make. But there's something else here as well, where since these DOIs or IGSN IDs are resolvable, it would be really nice as an extension to have, let's say, a custom Dataverse metadata field, so that if an IGSN ID is recognized, you could show a nice little kind of preview of the sample, the core sample metadata, as part of the Dataverse metadata list, so that you would easily be able to kind of browse and reference which samples were involved in as part of that research output. Yeah, so next steps, I kind of already covered some of this. Also building the FieldMark and RSpace integration and this Dataverse improvement are the next steps to really consolidate that whole workflow. And yeah, I'd love to learn from you and your use cases, thoughts, comments, dreams, concerns. That's my email, and I'll be around here. So yeah, thank you so much for your time and attention. That's all for me.
Slava, again, for multilingual semantic search in Odyssey. Am I pronouncing that right, Odyssey? Portal. And then we have one more talk after that, and then we'll have our QA. Go.
Thank you. Yes? Thank you.
Okay, great. Yeah, it's me again. So I told you how we're using AI and we're building sustainable infrastructure in Odyssey project. Oh, I don't know what's going on here. Yeah, okay. Yeah. So before I will tell you about Odyssey, a little bit overview of research data management in general. So what we do, we are basically archiving primary object, and we are also keeping secondary objects in some of the projects. And we're also building linked open data cloud. And linked open data cloud is basically our aim in Odyssey project. We don't want to keep any data. We just want to build aggregator that will harvest all available metadata with rich metadata standards, and after it should be should be aggregated and should be also available in semantic search. So Odyssey portal is just Dataverse, but it's slightly different usage of Dataverse because we are ingesting metadata records from our data providers, delivering metadata in different standards. And we are, of course, standardizing those metadata and publishing on portal with Dataverse with some embeddings. So with some keywords that people can use to find more information. So here's a comparison between Odyssey portal and data station. Case yesterday told about data stations, and this is about primary objects. And in Odyssey portal, as I said, we don't have any data. We're just dealing with metadata, and it's slightly different solution. And there is ongoing discussion at DANS what to do with it, because it's the same technology, but configuration is completely different and setup is completely different. And even service is connected to both data station and Odyssey portal. They're also different. So it's kind of different thing by itself. So we're using Archive in the Box. This is our outcome from SHOCK project, from European SHOCK project, which was finished in 2022. And we created a Docker setup that allows to integrate any kind of network services very quickly with Docker. And we're using, of course, control vocabulary support and automatic Solr reindex. So there are a lot of other features that could be interesting for you as well. And I already mentioned that data stations is our kind of core business. So we're building different Dataverse instances for different disciplines. And we decided just to split our Dataverse NL instance for different universities into different, let's say, platforms. And we're customizing every platform according to requirements of coming from specific community. So ideally, it should be distributed, and this is why I was talking about knowledge graph. This is a way how you can actually take care only about data itself, without taking care about what kind of technology behind of this. And we can integrate, actually not only Dataverse inside, we can integrate any kind of data provider. Let's say, if we need some data from Hugging Face or from Google itself, from Kaggle, we also can get it inside by using the same technology. So it's really universal, and it's getting reused in a lot of places. So all started with external control vocabulary support, which was contributed by DANS originally, I think, in 2021. We made prototype, and after thanks to Jim Myers and to IQSS team, they really helped us to get it in production state. And now it's functionality of Dataverse, which is available for everyone. And this is really great addition to Dataverse, because this is a way how you can actually build distributed network of resources. And I already mentioned a lot of times ELST. In my presentation, it's published on Odyssey platform as well. It's but original is stored by CESDA, and CESDA is a data provider for all data archives in Europe. So next to ELST, we have a few other ontologies. And for example, this is CBS variable thesaurus. We have one of partners, and this is a statistic agency, biggest one in Netherlands, and they're giving us all variables, all information that they operate in Dutch. And I already showed you, now we're very busy translating this to English and trying to get all this stuff linked to other countries. So we're basically trying to integrate all ontologies and to get this as a knowledge graph available for everyone. So data integration, of course, you know about this functionality, and Vaidaja just presented they're using the same approach. So as soon as it's been in Cosmos, it's available on Dataverse, and people can just get it linked to a specific concept, and after it will become part of metadata. So there are a couple of integration challenges. In fact, there are more, but data providers usually deliver metadata in like own standard, or it can be also Dataverse, can be not Dataverse. We need to take care about any kind of metadata in any standard to be ingested in Odyssey portal. This is why we're building specific pipelines, and they're reusable, open source. You can also, if you're interested to build aggregator, you can just get it from our GitHub and deploy, and after you can adjust slightly, and should be able to get all this stuff inside of Dataverse. So this is great. And there is also disaggregation control vocabulary linkage process, and I showed you this usage of AI. It's kind of possible in the future to get exact linkage to all concepts, and by using knowledge graph, it will be also available for everyone. So this is also quite interesting, because at some point we decided to do conversion of Dataverse metadata schema in also in knowledge graph. So there is work on getting fields like term URI linked in Dataverse schema, and after this information is being ingested in knowledge graph like normal control vocabulary as well. This is how it looks like. It's also published on GitHub, and it was outcome of our Dutch national project called Claria. So this is really like a list of triples, and this is metadata schema, all fields converted into triples. And also, we're taking care about all relationships, so it's really hierarchical, reusable, and I really hope that in the future, Dataverse will go in the direction of getting all metadata schemas in knowledge graph, not like now in just CSV file, and this CSV file is really difficult to handle this, you know, to get something done with it. So new metadata fields also available in our Odyssey portal. Sometimes data provider is asking us to add those fields, and we're using custom metadata blocks. And those metadata blocks also part of standard distribution for Odyssey, and could be also reused by other partners. And what is really remarkable about OAE export that was contributed by Jim Myers some time ago. If you export this, it's graph. You can just directly ingest it in a triple store, and you can query on it. I don't know if, Jim, you know about that, but this is really great, and it's really helping us to go forward. So after it's in a triple store, you can just write Sparkle query, and you can get all stuff that you want. That's unbelievable functionality. It's all available for everyone, but it seems nobody is using except of us. So now I'm coming to the topic of semantic search. So of course, semantic search was mentioned a few times already. And what we did about that, we started to enrich Solr index with all terms we are getting from AI, we are getting from different control vocabularies. It's all been ingested in Solr, and now it's available in standard search line. So if you search for a term in Dutch, you'll find datasets in English, or if you'll search in Chinese, you'll find datasets in Italian. Doesn't matter. It's really like language independent, and it's also a very kind of basic step, because we want also to search inside of knowledge graph. So we want to get all hierarchical relationships, and for example, by searching Netherlands, should be like find all cities belonging to Netherlands. This is what we are aiming for. So also Dataverse metadata enriched with standard control vocabularies like ELST, and all this information is being ingested by external providers as well. Like SSD is running own harvester, and all this information is already available for them. And I mentioned Sparkle queries a lot of times, and we understand that for human, it's very difficult to create Sparkle query because you have to know about all ontologies, you have to know about all stuff, what is inside your graph, and it's quite difficult for human. So there is a kind of service that was created to help with it. So we started to put all Sparkle queries in GitHub, and it's stored like in GitHub together with service that allows to connect to GitHub and also to get Sparkle query executed. So you can really like make it sustainable and also kind of exchange with artificial intelligence. So it will understand what kind of Sparkle you are using, what kind of control vocabularies and ontologies you have, and it will help us in the future to build a more robust infrastructure. Thank you.
Okay, because we've had so many talks, we're gonna switch up the schedule just a little bit and have everybody go and do a coffee break. We're ahead of schedule, and if we stay ahead of schedule, we can have a nice QA panel. So if you can take a 10-minute coffee break, bathroom break, whatever you need, come back, we have one more presentation and then a QA. All right, we're gonna start with our next presentation. Paula, tell everybody to come inside and close the door, please. Yes. Tell them to come in, and they took a longer break than we told them to. Gracias. All right, our next presentation is going to be leveraging persistent identifiers for enhancing fairness and interoperability in data repositories. We have Paula Mejia and Arturo Garduño Magaña. Yeah, I've learned how to say your name.
Thank you so much. Thank you so much. Welcome back, everyone. I promise this is the last time you're going to see me on stage today. Let's go. Okay, just a little recap about the persistent identifiers. We have been talking about this topic for a couple of... Oh, yes, but... No, you can. Hello, can you hear me now? Perfect. Just a little recap on what we have been talking about, the persistent identifiers. We, for those who have not had the chance to see the other presentations or be in the workshop, we know that the persistent identifiers can help us to track and to identify particular people or researchers, including the ISNIs or ORCID IDs, the persistent identifiers for institutions, like the ROR ID, and of course there is a wide variety for persistent identifiers for things that we have been also discussing today, like DOIs, handles, IGSN, ARCs, and many, many more. A little recap on how the DOI are structured. Basically, they are very similar to URLs, but the thing with DOIs is that they are not only handles or not only unique resource identifiers, but they are also accompanied by metadata connections on behind. And this is how you're going to see, I assume everyone or most of you have been familiar with DOIs. And talking about the connection metadata, the importance of having these representations and these connections is to understand how research is being developed and being well executed. We know that thanks to these connections, we can identify how a data set can be cited by a paper, by who is created, and this person, where is affiliated, and if there was a funding, where it came from. So the important here is that we can understand and track all the research life cycle and the ecosystem, and understand in a better way how we are doing science, how we're doing research, and how we are well advancing on this. As mentioned before, the role of persistent identifiers in the fair processes or in fairness is really important, but not only by themselves. The metadata that are associated to DOIs is important, so we can provide findability and accessibility to all these resources. Of course, to provide interoperability thanks to the knowledge representation and thanks that it can be readable both by humans and machines. And of course, a very important part for for us here is the reusability of the data, thanks to the metadata that can be richly described with a plurality and accuracy and relevant attributes. As mentioned before, bits are not only for digital objects. As we know, the research lifecycle is composed by many, many elements and many outputs. And for us, it's also really important to have the chance or the possibility to assign and connect from the physical objects when the research starts to the last outputs of the research. Name the data set, the image, the software, the articles, the thesis, the book chapters, etc. Now, going a little bit more in detail with the research, the data repositories, of course, but one important element is also the how can we enhance accessibility with these persistent identifiers and metadata? Well, as mentioned before, they are really needed to enable the fair research. They are elements that can help us to achieve those goals. They can help us to enable the global scaling of research through this unique and standardized identification and scholarly entities. We can also understand how the research impact is happening through the interoperability and the connectedness of those elements. And of course, it can improve the trust in the research by facilitating recognition and preservation for this diverse range of outputs mentioned before. It is also relevant to mention that we are striving, or we are pushing for this idea that also the persistent identifiers can help us to improve equity across the different disciplines and countries by increasing the recognition of the research contributors and the different contributions. Sometimes, and you may be very familiar with this, when we tend to identify who is the person or who are the persons behind the research, sometimes we tend to forget many other people that are part of the research life cycle. So with these elements, we can connect and we can provide credit and we can provide acknowledgement to everyone involved in the research life cycle. A little bit of best practices at the time of implementing persistent identifiers. As researchers, we can identify, manage, and share research outputs, of course. We can also cite data and other types of resources, and of course, to learn about and utilize the existing infrastructure and services by also engaging in open research agenda settings and these kind of events, of course. As institutions, this is also really important because by supporting persistent identifiers and its metadata connected, we can help to lead the community of practice. We can help to prioritize the openness and the interoperability, and of course, to generate all the elements and all the normative and the steps to generate rich and comprehensive metadata. And also, one important element that has been discussed a little bit in the past days is the role of the funders. By setting output tracking goals, by implementing funder or grant IDs, for example, we can help to guide researchers to effectively manage data. We can also track and understand how the research that we're funding is generating an impact. And of course, by engaging with other stakeholders in the community, we can encourage an uptake. Now, going to the terms of the challenges, one important element here is the governance. This is something that we have been discussing a little bit, but by establishing clear policies and procedures for PID assignments and management and ensuring compliance with relevant standards and regulations, we can help, or we can identify this strategy, we can implement these strategies to try to overcome these common challenges. In terms of sustainability, by securing long-term funding and resources for maintaining the PID infrastructure, that's mentioned before, by addressing technological obsolescence and evolving standards, and by developing sustainable business models for PID services and support, we can also try to overcome these sustainability challenges. And finally, in terms of the community adoption, sometimes we can find or identify this resistance to change and this inertia within the community, but I think that by building awareness and understanding the benefits of the implementation of identifiers and collaborating with the different stakeholders to address specific disciplinary requirements and preference, we can also overcome these situations. It is important to note that these are elements for a general purpose in terms of the persistent identifiers, but also we wanted to present you the experiences of the data repository. So we invited Paula Mejia and the team of the Tec de Monterrey to present you a little bit of their experience. So, Paula.
Hello, you can hear me? Yes, okay. So now I'm going to give you a glimpse of our repository. We're going to present at 4 p.m., but I'm going to explain how in our Research Data Hub platform from the Institute for the Future of Education, we work with educational data and institutional data. So we are only like a branch of our repository. There are other schools and other institutions that are going to be working with their own data sets. So we only focus on educational data. So we have collections and data sets. The collections are the institutional data given from different departments, including students, professors, opinion surveys, graduates, and this type of collections. And we have specific data sets. For example, we developed and validated a data set called Student Dropout. And also we have a competencies-based model, also data set, which are specific data sets that are given for call for proposals. And we have also the part for request. These requests are managed through the collections. So researchers can come with me and ask, I need student data, I need professor data, and we kind of personalize those data sets depending on what the researcher needs. Okay, so now here is an example of how our repository is developed. For example, in the student collections, we have 7 DOIs, 7 collections, the student professors that I mentioned before. And for example, for that collections, we have already 3 scientific publications. And in our data set, for example, from Student Dropout, we have 9 scientific publications. So we can see that, for example, when we develop a specific use data set, it is more easy that researchers are eager to ask for it because this has a specific objective. So in here, the practical example is the data mobilization process that we developed. We created a data descriptor for the student dropout data set where we explain everything that it is included in the data set. You know, the variables, the definition, the different types. And also we generate like some graphs so that the researchers can have like an idea of what is contained in that data set and it is attractive to them to ask for it. So from that data descriptor, we have 7 articles and 14 citations. Here we have 2 DOIs, one for the data set and one for the data descriptor. So this is like the importance of having DOIs to generate data mobilization. So for example, we promote data-driven research in educational innovation, which is our core in the Institute for the Future of Education. We increase the research visibility by assigning the metadata. We provide accessibility, like to validated queried data. We also manage that data sets. We are sure that the variables that we are giving are validated through many departments. And we support the persistence of the data set by being reliable located. And thanks to these DOIs, we can trace and track and have like the metrics for citations. So if you want to know more about what we do and how do we mobilize that data, you can see us at 4:20 p.m. Thank you.
We are up for our QA. So everybody who was speaking this morning, please have a seat on the stage. Yep. Okay. I think I accounted for everybody. Let me know if I'm missing a chair. Okay, I know we had some questions on Zoom to start, and we have questions here. So, oh, the people online, correct, okay, that's what I was saying over there, I knew there was a reason I was out here. Yes, thank you. So welcome to our morning QA panel. We have some questions that are coming in from the online attendees as well, but if we'd like to start here, does anybody have any questions to start from the morning session? Dimitri?
Thank you. One question about the EGSN identifiers. What do we do with existing DOIs which were now fitting the EGSN use case?
Sorry, the DOIs that you establish to another physical object, for example?
Exactly.
Okay, well, the idea, there is a lot of things happening in terms of the best practices, but the idea here, and Rory Edmonds is going to be the best person to answer that, but I'll try to do my best. The idea is to try to not necessarily migrate, but change this, how things are doing, to establish a process where you can now identify this more specific and more suitable identifier to the physical objects, because it's going to be representative of what the outcome means. And all these objects that were assigned by, I don't know, by certain decisions to a DOI to try to connect probably the research, there should be and there are standard process where you can migrate that to a suitable IGSN ID. It is important also to mention that, as mentioned during the presentation, the IGSN IDs are also DOIs, or are basically DOIs. So there is not necessarily, in terms of how it looks like, it is not complicated, but in terms of what is back of that, in terms of the description, in terms to identify that it is IGSN ID, we can help to that process directly from DataSite. So we invite you to contact us and to reach at us with that particular situation, so we can help you to migrate all these existing or pre-existing DOIs.
Thank you.
Okay, well, actually, yep, Jesus.
Thank you. So my question is for Shalava. In your first presentation today, you said, if I understood correctly, that if you run your algorithm several times, you will get different relationships between a specific pair of concepts, correct? So my question is the following. Have you tried to get a richer ontology by combining the outputs of several runs of your algorithm? And if so, do you normally get an increased accuracy or rather higher levels of noise?
So basically what we'll get in this case is new set of embeddings which will represent relationships in some ontology AI created. And as more experiments will run, we'll get it even more variations, and we'll get it even more rich. So yes, it's very useful, and yeah, if you would like to test it, we also have a service which is available for public.
Okay, thank you so much.
Okay, great. We had one question this morning, Stefano, for you. Does the plugin ever send the data somewhere outside of Dataverse? Is this thought process you're showing exposed to the user in any way?
Okay, so for the moment, the data are sent to the external tool. We are talking about open data, and no personal information is sent toward this tool, but the external tool now uses ChatGPT. So for transforming the natural language say question or query into an SQL query. So that part is sent to the LLM. The analysis of the data is all local to the tool, which runs on our own infrastructure. And but the tool is written in a way that you can plug your own large language model. So you can, in principle, run an LLM like Llama 2, like Slava is doing, on your premises, so no data is flowing anywhere. So that's the answer to the first question. It's a proof of concept. So the idea is that we can improve it as much as we want. And the other thing is, the other question is about if the chain of thought is exposed to the user. No, at the moment, no. Just because I decided not to show it, it can be confusing, but it can be in practice because it's just the output of the tool, so it can be put side to side with the data, and sure.
Okay.
Probably chain of thought also should be considered with attention.
Yeah,
Yeah,
I mean, it's
so you can
based on the
leverage
same
this,
idea of
yeah.
attention. Yeah. The agent just try to understand which words, which part of the sentence is meaningful, and try to transform it.
Okay. And then Sherry.
All right, thanks for the interesting talks. So my question goes to the semantic search and the sentence embeddings. It's a really powerful tool to find things, but do you also plan on implementing something as related data sets on the SPA level, where I can go into a data set and see that those other data sets based on these sentence embeddings are kind of similar? Because I think this would be extremely powerful to go through things, let's say experimental data, and then have the modeling right there and so on. Do you plan on something like that?
I think we are both doing this in a sense. So Slava as the graph. So the knowledge graph will have, I mean, you can answer yourself, but the knowledge graph is I think it's meant to do exactly this. And in our case, if you just use the plain embeddings, you have a distance. So and because this distance is in this space, you can query actually, which is the next data set close to the data set I just found, and you can follow the path. Yeah.
That is incredible. Thanks.
I can answer what we're doing. So we have all this information ingested in the knowledge graph already, and the only problem is just to get a Sparkle query, but by using AI, we can also do that. So in a way, we have all components, and probably during next community meeting, I will already present something related to semantic search with relevant data sets.
Nice, looking forward. Thanks.
Hi, this question is for Vaida. I'm not sure, but the question is about when you push information over to the data set, Dataverse, can the end user then go into Dataverse and change things, and then does it get propagated back? Because you talked about the DMP tool thing get propagated back. Can you sort of elaborate on that?
Yeah, for sure. And this was something we talked about a lot when we were discussing with Fieldmark and Dataverse and in RSpace. Ideally, you have this kind of like Git-like system, right, where everything can push and everything can pull, but that's a lot of work for each part of the process. In the case of Fieldmark, we just assumed in the base workflow that you do field collection, you push the data forward, you don't need to pull it back in, right? In the case of Dataverse, once the export is generated and it's populated, you can edit it manually, but in that case, yeah, it doesn't get passed back. And I think it depends on the context. If there is a need for that to happen, then we can do that. But I think it's kind of one step at a time and trying to see which of these links and kind of updates are necessary. Because if we pass the Dataverse DOI back to RSpace as part of the landing page as a related material for the sample, then you can reference that, and all the information is in Dataverse. If Dataverse, someone updates the information there, you're always seeing the latest version, and the other way around. So we're really trying to separate out the different components so that the source of truth is only one version in one place.
Any other questions?
Question to Stefano, but regarding other presentations. We saw in the various panels the importance of links between the identifiers and metadata, and especially the case of IGSN going into the related materials field. However, this related materials field is not sent to DataCite, so we don't have a trace outside of the repository of this link. Are there plans to have better exports to DataCite of those kinds of relations?
Yeah, mean, there are plans to have lots of exporters and better exporters, and we can definitely include this one too in our list. So the co-petition, the GREA co-petition is trying to work this direction with all the repositories. Yeah. And if you want to contribute.
Thank you.
I mean, the idea is not just to have better exporters, but also better importers, so that we can remap whatever comes into the actual metadata structure, which not everyone likes, and export in another structure that some people like. And LLM can help.
Okay. Anyone else? Question? Back this way. Sess.
Yeah, thank you for the excellent presentations. I was really intrigued also by the sessions on the identifiers for physical samples and physical objects. And I was wondering how this interacts with big institutes that already hold large collections of physical objects, like museums and herbaria and so on.
Yeah, no, for sure, especially for Rothamsted, where it wasn't about collecting field samples for new studies. It was about, we have 2 million samples. What do we do? And I think Arturo will be able to add to that a bit as well in terms of how DataCite handles that. But we just kind of decided to take the simplest use case of, from now on, you're using these identifiers, and let's try to make sure that that's okay. And then, as a separate problem, let's figure out what we're doing for the existing ones. So it's, I mean, ideally, we would want to do that kind of migration, but there's also the question that some institutes that are quite advanced, they have their own landing pages already. And obviously, those aren't, API formatted in the way to interact with external systems. So that's an extra complication. You don't want a duplication there. So yeah, my answer is just, watch the space.
That will be the next step, because indeed the biobanks, and there are things called life science identifiers being used for some of the life science collections. So, okay.
As mentioned before, it depends also on the level of the collection and what you are intending as an organization or as a researcher to do. So you can decide if you go by with every sample, or if you want to make these volume collections where you can identify where you can gain a lot of value by joining them or by considering them as a collection. So it depends a lot, but yes, it is not one way to go. It depends on how do you wish to manage that.
Thanks.
Any other questions?
Using the fact there's no other question. Another rebound on the links between identifiers, because LLM, I think it's an interesting option to identify new links, but we also have the existing links just from other sources. And one way to get those links would be the link data notification, which has been implemented in the first version, but still in a draft. Could that be integrated to the funded perimeter of NIH grant or another program that would allow funds to actually go on these technical aspects?
Yeah, that's a good point. But I think it's still not yet in the plan, but it's something to discuss with the other members of the co-petition.
Thank you.
At Harvard, we use something like, we use core notification to notify between Dash and Dataverse, but yeah, it's not yet what you ask.
Thank you.
Oh, and actually, just to add to your previous question about, the DOI of the Dataverse export being sent back to the IGSN schema. So it's something that we can do when our space pushes to Dataverse. It knows that that event happened. Take that DOI and update the IGSN field, so Dataverse doesn't need to do that work because we're the ones actioning, so we can do the update as well. So again, the kind of separation of who does the work and bundling those works together.
have a question, comment based off of that. So with the linked data notification with Dash, the preprint repository at Harvard, right, and that LDN code is in Dataverse, so you could use it with other ends. But the way we implemented it was basically when somebody claims over in Dash that there's an association with a data set, we send the notification, and then essentially we alert Sonia, right? Because we basically don't want to automatically update the data set with something that we may not trust because somebody got over in there and right, they're lying over there and we don't want to change things. So I think it's sort of common question if you thought through, you know, especially with things like LLMs that are going to hallucinate, how do we distinguish between things that are trusted to be part of the data set and stuff that has been basically assumed by some other tool, which you may, or you don't want that to become mixed with the metadata in the data set that the author has claimed is true, right? So how are we going to deal with that if there's any, do you have any comments on that?
I think we discussed this at lunch. So the idea is to, whatever metadata is automatically generated or imported from, say, an activity which is not done by the contributor of the data itself, can be marked as such. So clearly marked in the database and in the UI, so that the user who accesses the data knows that this information is automatically generated or whatever.
I can also add to it. I just presented decentralized identifiers, and this is exactly use case for decentralized identifiers. So on top of DI, you can create another identifier that will include all activities produced by artificial intelligence, and could have a linkage to provenance information from where it's coming, which model was used, and it's also kind of dynamic process. It could be updated in real time with new resources, and this is basically how you can distinguish original data set from artificial data set, which is enriched with other stuff.
I have a question. Can I put a question to the panel? So about the ID, what's the difference between this idea and ARK? So the other distributed identifier.
I think the most of, difference of the ID and other persistent identifiers, that it's really cryptographically signed. So you have private key, and as soon as you are creating new identifier, you are responsible for this key. So it's in your own ownership, and if you lose it, you will lose access to data.
So in a sense, it's more risky than ARK.
That's right.
You don't have this piece in our ARK.
Yes.
Yeah, I just wanted to comment on ARCs because, right, essentially they're a kind of identifier that can distinguish between this data set as managed and archived by this group and the same data set as managed by someone else. And that potentially gives you the way to say that over here, that identifier is extra metadata because we put some extra services around it, but it's still the same underlying data set. So I think there's some legs there. So that might be an interesting way to go.
Thank you, everyone. Thank you to our panel. And so lunch starts at 12. 1 o'clock, please be back at the main building where the flags are for a group photo. Okay, taking attendance for this photo. So thank you, and we'll see you guys this afternoon session. So just a reminder that at 2:50, there is a parallel presentation workshop on the technical overview and front-end developer's guide to the Dataverse architecture. That's in the meeting room 10, which is right outside and down the hallway in this area. If anybody wants to go to that talk. Technical overview and front-end developer's guide to the new Dataverse architecture. Ellen is going to be providing that workshop at 2:50. But for this afternoon, we are going to start with data curation and sharing with Data Curation Tool and Data Explorer, followed by revamping Dataverse. Maintenance. Is it okay? I was just screaming, huh? I don't need it, that's why. maintenance extension and a future-proof design for a widely used library. Then we have process of technical requirements gathering for the integrative solution of the Fiocruz Research Data Repository, Arcadados, with the Research Electronic Data Capture RedCap tool. Then we have another talk following called Using OIDC to Support Dataverse Integrations in a Research Commons Environment. And then we will have a QA panel. So really it's about not even an hour, maybe a little over an hour of presentations. We'll have a QA panel and then there'll be a coffee break before the next session starts. So I'm just going to give everybody time to get settled in here and then we will begin. I'm the only one that holds it up, that's why. Then they tell me I'm speaking too loud. Oh, don't forget soccer. Gustavo has his own team. Okay? It's everybody, it's Dataverse community versus Gustavo. It's a real battle. Joining your own risk. We take it very seriously.
No, I didn't get it.
To introduce you,
Oh, sorry.
just briefly. I will introduce you briefly, just where you are. You know everybody knows you already. The Zoom community might not. Everybody's coming, so got them in there. Got them in here. And is Victoria here? No, she's not. That's what I thought. All right, everyone. We're going to start with the data curation and sharing with the data curation tool and data explorer. And the additional co-authors on this are Nana Boateng, he's a programmer analyst at Scholars Portal. And we have Victoria Lynch as well, programmer analyst at Scholars Portal. But this presentation is going to be by Amber. Take this. Okay. So you need that instead.
Okay, great. Let's get started. So I'm going to talk to you today about data curation and sharing using two tools that are external tools to the Dataverse repository and that we've implemented at Borealis and Scholars Portal. So just a bit of background, at Scholars Portal, we've hosted and established a Canadian social science data repository called Odyssey, which contains a lot of Canadian microdata, survey data, public opinion data. And we were using a different repository up until last year. So in October of last year, we updated Odyssey and fully migrated all of the DDI metadata, data files, documentation, deposit and curation workflows, data sharing and reuse tools, user guides, and more. Just to back things up, what am I talking about? So I'm really talking about this tabular data, the survey and public opinion data in our Odyssey collection, including many types of formats, which you see here, as well as documentation, including questionnaires, codebooks, data dictionaries, and DDI metadata, as well as variables and questions, including values, codes, categories, labels, question text, universe, notes, and weights, all captured in DDI metadata format. And on the side, you can see the new front-end interface, which supports searching all of this metadata and data for discovery and access. when we talk about the reasons why we developed this front-end tool, many of you have pointed out that the variable search in Dataverse is not quite as robust as maybe end users would like to see. For our community, we had hosted a catalog attached to the repository for many, many years, and it supports all of those enhanced discovery and search features for our users, so we just built this on top of Dataverse. You can see the variable search pulling from the variable metadata in Dataverse and displaying it for end users in the matching variables search use case, as well as all of the Dataverse metadata supports filtering and faceting on the Odyssey catalog. So I'm going to show you what this looks like. I'm going to show you how we search collections, including browsing, full text anywhere search, search by title, keyword, all those controlled vocabulary fields that we have for the Odyssey data collection, as well as the variable and question searching and the matching variable search. So here you go. So this is the front end. We allow our users to filter by these fields. They can also run a full text search. So I'm just showing you an example of doing a search on Trudeau, who's our Prime Minister in Canada, to see what data collections we have. In this case, this is actually going to pull from data for a particular year, including 1970 to 1977. So it's actually not our current Prime Minister that I'd be finding in this collection. It would be his father. So here's the browse feature, where you can find it on the interface. Pulling again from the topic classification field in Dataverse, which is a controlled vocabulary in our collection, we are able to show the topic that we have in our repository. These are the Odyssey subjects. So we have a subject called public opinion polls. And from there, the metadata search system that we have attached on top of Dataverse supports the front end to be able to display the series name that topic data set has, and then aggregate those and present them to the user, including additional information, which is also stored in Dataverse, including the year of publication. These are all the collections that we support. All of Odyssey, everything that's checked off there has been migrated to Dataverse. We also support partnered collections, which utilize the DDI standard, including ICPSR. This is just an example of how those controlled vocabularies come in very handy for classifying and grouping data sets for people to filter and drill down into, including dates of publication, geography, language, distributor, and kind of data, which are all standard fields in Dataverse. By default, when a user searches, they're presented with data set results, which include the title of the survey, the snippet of where the search term appears in the full text, as well as that same term search only at the variable level displayed as matching variables, which allows the user to preview the variable summary statistics and chart frequencies. You can also save the citations, and you can drill down into a particular data set and look at in more detail at it. The preview variables feature that I just spoke about, this is an example. The user would click on the matching variables button, and that would open up the listing of the matching variables, and they could click on them to display the summary frequencies as a chart. This is all out of the box with Dataverse. We also support a more advanced and customizable Data Explorer tool that allows the user to open the tabular data set in this Data Explorer tool, which is an external tool to Dataverse, but fully integrated with Dataverse metadata. And you can see you can view variables by their groups. You can look at summary statistics, look at frequencies, categories, and metadata for each of the variables. And you can also perform cross-tabulations or analysis of the data. This is the example of the current Data Explorer 2.0 analysis and cross-tabulation tool. The user enters the variables into the rows or columns, and it displays for them in a table format. This is how the user could interact with the tool to then download or subset the data and bring it into their environment. And so it supports that extraction from Dataverse and subsetting from Dataverse directly. We also have integrated an easier way to download for our users, including extracting using the Dataverse APIs to call those files directly, as well as to call the terms of use and present that to end users before they're able to download. I just want to highlight that data curation integrations do exist with Dataverse. We aren't currently using the curation labels in our curation process for the Odyssey collection, but that is a possibility, so I wanted to showcase that. We also, as a result of using Dataverse, needed to update our best practices, including our DDI metadata best practices and deposit guide, as well as our curation guide and deposit primers. These are all available openly online, in some cases in both English and French. This is the example of the social science metadata best practices section of our guide. So you can see these field names are familiar. They're all coming from Dataverse, and they're pulling from a previous best practice manual based on DDI, and we've upgraded to be based on the latest version of Dataverse. This is the variable metadata section of the guide, and it describes in more detail what elements of the variable metadata are system generated and which ones are customizable using our data curation tool. The data curation tool is a back-end tool that we use only for curators and depositors and owners of tabular data sets to enable them to edit variable metadata, to add question text, to add universe notes, to add variable groups. This is the example of the current edit variable metadata form in the data curation tool, which allows you to enter variable metadata and save back to Dataverse's database. These are the outputs that are generated by Dataverse after enhancing the variable metadata, including DDI codebook XML and an HTML version for end users to read. I want to showcase some new features that we're developing to support a new release of these tools. So I encourage you to go to the GitHub to take a look at what we're doing, but I'm going to show some highlights today. This is the new tool. It's a fully integrated tool, a single application that combines the data curation tool and the data explorer tool. This is the new view variables view that will allow users to interact to select categories that they want to view. If they don't want to see all the valid skips or don't knows, they can turn those off. We also allow for iterating through the data set. Instead of opening up each variable on their own, you can now use this view to iterate through the entire data set to interact with the data, to view frequency charts, weighted counts, turn on and off missing values, and to view question text universe notes and summary statistics. This is the new Edit Variables button, which again is all fully integrated. You can toggle between view and edit if you are authorized to do so, and you can continue to edit and add variable metadata as the same as before. We're also working on a new feature to import from DDI, from external sources, or from Dataverse, and to generate additional formats of the codebook, including PDF. I also want to showcase that we're working on a new cross-tabulation feature that would allow you to select variables, to add them to your rows and columns, to add a title to your table, and then to generate that table more dynamically so you don't have to interact with multiple windows. So this is a mock-up one, and I encourage you, if you have any thoughts about what you'd like to see here, this is just a mock-up, and we're very much in the process of developing this. So if you like this or you have ideas, please let us know. And this is the mock-up too of what that could also look like. And this is an example of the import DDI variable metadata for curators importing and reusing variable metadata from the existing repositories or from the same series of the data in our collection. So I just wanted to reiterate, there's many external tools, as we've heard this week. You can quickly and easily add these tools to your installation of Dataverse. All you have to do is download a JSON manifest file for each tool, configure the tool with a curl command in your instance, and install and host these tools. You have three options. You can either use the GitHub hosting, which is already there and available out of the box. You can set this up with inside your Dataverse application, or if you're using it for data at a larger scale, you can set up and host this as an external tool connected to Dataverse with a separate web server, which is how we host it. From there, your users can upload tabular data, and the button for these tools will appear for them in the drop-down menus. Oops. So as I mentioned, some ongoing developments related to this work is we are currently in the process of getting a pull request merged for the PDF codebook export option. We're also actively scoping out how we can support better file format conversion, including export to CSV instead of tab, as well as allowing end users to select their preferred statistical format at the point of download. We're also implementing the import DDI XML feature, which I talked about. And I think overall, we're really interested if there's anyone willing to work with us on improving the performance of tabular data ingest in Dataverse, as well as the cross-tabulation design and performance improvements needed on the Data Explorer tool, and supporting additional enhancements to the cross-tabulation features, including weighted cross-tabulation options and export to PDF or Excel formats from the crosstabs. So I just want to leave you with some resources, including more information about Odyssey and some guides that we've created about our public opinion polls collection, about certain collections within Odyssey, as well as all of our best practices and the wonderful guides at the IQSS and Dataverse documentation side. Okay, that's it from me. Thank you.
Next, we have, they can hear me though. Next, we have revamping Pi Dataverse, maintenance, extension, and a future-proof design for a widely used library YAN range. You're welcome. You might want to use it. If you need it, I'll leave it.
I think that's okay. Can you hear me well? Okay, perfect. Okay, perfect. So, hi everyone. As I was already introduced, my name is Jan Range, and I'm a research software engineer and also a PhD student from the University of Stuttgart in Germany. Yeah, I want to give you some context on actually my history using Pi Dataverse. Yeah, I started as a user actually, using Pi Dataverse and going to having it as an introduction to Dataverse itself. It was an invaluable tool for me, and it's still today. Fast forward to now, and I'm happy to today give a talk about revamping Pi Dataverse and talking about maintenance, extension, and also future-proof design for that. Yeah? Let me start by give you a small introduction about what Pi Dataverse actually is. Yeah, I mean, maybe you know it already, but it's essentially a Python library that allows you to interface with Dataverse. It was originally developed by Stefan Karsberger until 2021, and he did a really great job at that by implementing an important subset of all these endpoints that are existing at a Dataverse installation. And it's quite a popular library, actually. It has 59 stars on GitHub, which is a lot, I think, and it's the best on GDCC, so it's kind of the highlight of the organization. On the other hand, you also see that there are a lot of dependencies that are using PyDataverse actually. So there are currently 72 repositories that use that. So it's really popular among all those Dataverse users, and that is extremely nice. Unfortunately though, due to financing issues and also like Stefan going to a different work, the development of PyDataverse has stalled. So you can see that right here on this commit graph right here. We have some peaks right there, but right after 2021, there's not much happening. And it's a pity actually, because there were some bugs and issues that kind of, caused some problems. Parts of the library were broken and were not usable, I remember that uploading data files was bugged and also like replacing them. And it's a pity because, I was using it so extensively and I would love to continue on that. And so in order to work against that, Phil, Oliver, and myself, we've met in end of 2023, and we were talking about the future of PyDataverse. And we were all agreeing that we should change that, the current state, and revamp that. In its essence, this was the birth hour of the PyDataverse working group. And the goal of this PyDataverse working group was not only to fix issues and continue the maintenance, like working on pull requests and everything, but also to continue on what Stefan has actually began, so to continue on his vision and his legacy. I always try to see it in that way. We're taking this old flower and we're treating it like gardeners, to getting it back into its full glory, and maybe at some point also into a long-lasting tree. I know this is biologically not possible, but in the programming world we have different rules. So that was pretty cool. So we started with that, and initially we thought about how can we structure the work that we're doing with this working group actually. So we've identified a couple of phases. Unfortunately, those symbols are kind of off, but I'm sorry. So these 3 phases were at first, of course, first aid, fixing the unavoidable to make it work again, establishing a new CI/CD pipeline to get the testing done so everyone can contribute, and of course, fix all these urgent bugs, After that, we planned, and we're already in the process of processing everything, which means we want to address further issues, pull requests, and extend the testing framework and some features. And last but not least, this is the most interesting part, I had to say, is the extensions, like visions we want to implement in PyDataverse and make it bigger as it is already. So in terms of first aid, we have already done some work, and this is already a preview of what is coming in soon, So as I've already mentioned, we were re-establishing the CI/CD pipeline. So testing is now working pretty well. We are using the Dataverse GitHub Action for that. I want to also advertise that for other software developers. You can use this right now in your GitHub Actions. And with that, we already built a new testing workflow and also a PyP publishing workflow. This is not yet submitted as a pull request, but it's coming, And last but not least, we fixed all these urgent bugs, and you can see soon we will release the new version that you can use then, In terms of processing, we have already addressed a couple of issues and pull requests, So those weren't really urgent at that time, but we're working at it. We are also in the process of extending the existing PyDataverse library, One of which is to make it async ready. For those who are not aware what async is, it's basically a way to have concurrent requests to an API so that you can process a bulk of data and send a lot of requests and bombard Dataverse in some sense. Due to previous work that we already done, we've done a switch from the library requests to HTTPX. It allowed us to have kind of a hybrid setup to do either async or sync in the same way. So that's kind of cool. The other thing that we also want to add is the Python version of the DV uploader, because currently the data file upload with PyDataverse is kind of clunky. And with that implementation that is also on GitHub, you can do a lot more than that. You can do also the direct upload to S3. So if you have big data, you can use that right away. And also it supports parallelism. So if you want to upload a lot of data, you can do that. In a recent case, is something that I worked with Don Richards. He wanted to upload 400,000 FITS files, and DV Uploader managed it in a pretty reasonable, good time. So this would be a valuable addition to PyDataverse itself for those who are dealing with a lot of data. Yeah. Now the next part, and the most interesting part I would say, is the extension. Yeah, we want to add high-level concepts, robust models, so we have data validation, not at the part when you send something to Dataverse, but when you're already preparing everything. Yeah. So for that, I also wanted to show you this this schema right here. Yeah. So we envision that we have two APIs in PyDataverse. First of all, we have this low-level API. This is what PyDataverse is already. Yeah, we have implementations for the Dataverse endpoints and also for the model schemes. And we want to add something on top. Yeah, that's a high-level API, kind of an abstraction of what you can do with multiple endpoints. Think of it as recipes that offer something to you, a bigger concept, in a more easy way. There are two cases that I want to present to you on how we can realize these high-level features. So one of which is something that was developed by Oliver Bertuch, which is DVCLI. And as the name suggests, it's basically a command line interface to PyDataverse. Yeah, because sometimes you just don't want to script everything, you just want to do it by the terminal, and in this way you can do that, like uploading files via that, or configuring everything all at which in there. I think it's a pretty cool thing also for people that are not really too much into Python itself. I think it's quite cool. Another thing that serves as a high-level concept is Easy Dataverse. This is also a library that I've built in parallel to PyDataverse and used it a lot, which essentially is kind of a layer that simplifies certain things. I believe everyone who has already submitted a data set via the API to a Dataverse instance knows how complicated this Dataverse JSON can be at the end. Yeah. At the beginning, I was presented with this Dataverse JSON, and I was having my hands on my head and thinking, oh, that's a lot to learn, actually. But what I've realized on that sense is that it's quite static, and that you can build software around that takes it and simplifies it. Because, hands down, I mean, as a user, I don't really care if this is a compound field or whatever. I just want to have my metadata block and assign a specific title to that, nothing more than that. And that's essentially what Easy Dataverse does. Yeah, it connects to a Dataverse instance. It fetches all these metadata blocks right there, and it presents it as objects that you can just populate and then upload at the end. Yeah, you can also edit data sets in that way and update them, so it feels like a programmatic graphical user interface, if I can say that. Yeah, and we want to incorporate this into PyDataverse and work with that. Yeah. Another thing of the extensions that I think is extremely interesting, and that's kind of the main topic of today's presentation, is to work on this low-level API. Because at the moment, this is only manually implemented. Yeah, you got to have hands down and implement each of these endpoints by themselves. I want to give you an example on how you can do that right here. So this is an example of an implementation of the endpoint to get a data set. Pretty simple one, yeah? If we look at this, we can identify some requirements. So we need a URL. Where do I need to talk to? What kind of parameters are going into the URL? And to have some data to add, yeah? At the end, when all of this is together, we just use an HTTP client method and call to Dataverse and do that. But the thing is, implementing that feels like a chore, I tell you. There is nothing, I would say, in a creative way. It's always the same, URL, parameters, and data, you know? And when I realize something like that and see that, I think of something that we can automate, actually. And indeed, we can do that, yeah? And a good tool for that are the OpenAPI specifications. For those who are not aware what OpenAPI specifications are, it's basically a way to describe an API, yeah? That includes which URLs are available right there, what are the request and response bodies that I can use, and what are the types that are expected, yeah? Luckily, at Dataverse, we already have this OpenAPI specification, which was originally given by Payara, which was unfortunately broken, but JP, the savior, he saved it, and we now have a working OpenAPI specification to use that right here. Yeah, I want to quickly show you how such an implementation of an endpoint looks like. Yeah, to show you also the contrast to the actual code at the end. So if we look at that right here, this is a YAML formatted file right here. We see that on the top end, we have the URL that we want to speak to. Yeah. Next up, we're going to define the HTTP method. In this case, we have a GET method. And what we can do right here is define what is expected as a parameter in this URL. And later on, we can also define the schema of the response, so we know what to expect from that. And the nice thing is, with that at hand, you can actually generate code with that and do all the stuff that Stefan already did by hand. So essentially, the idea that we have with this extension of PyDataverse is to rely on this open API specification to generate the low-level API in itself. And the cool thing is that we don't have to do this by ourselves. And the more nice thing is that we can use the complete API, because currently PyDataverse only has 36 of these endpoints from 345, and that's quite cool. So we've looked in a couple of these code generators. Yeah, there are quite some popular ones. One of which is Speakeasy, which is from a company, and the other one is the Open API generator, where they have a Python and a Pydantic version. I found Speakeasy to have the best solution. I don't know why. I know why, but it looked really, really cool. Reasons for that is that this Python API is not just implemented in the classical object way, but they use data classes for that. That means there's type validation, which Python unfortunately not has. Yeah. Another point is that it requires the least code, so it's not as bulky as the other ones. And on top of it, it also generates a comprehensive documentation. You can see here on the right an example of that. It gives you everything you need to know. Yeah. So what do I have to put in? What can I expect from that? And it gives you a code example. Yeah. So if you want to just fetch a data set from a Dataverse instance, you can just go there, copy that, insert everything you want, and you're happy to use that. Yeah. I think that's quite cool and especially beginner friendly. Yeah. Another thing that's more of a technical thing, but that's what I really like about that, is that you can use flexible clients. Yeah, that means you're not restricted to just use the default requests library. You can use HTTPX, or you can even come up with your own. Yeah, I've been experimenting with putting also async clients in there, and it seems to work quite well. But the company itself has this async support already on their roadmap, so maybe we don't need to do this on our own. So in order to also prove to you that it works, yeah. So this is taken from the latest code generation is to list the content of a Dataverse collection, and you might be familiar with the output right here. It works, yeah. You may recognize that it's still this clunky JSON. Yeah, that's the reason of that is because that we still don't have the schemes of the response bodies in there, but I think we can still work with these dictionaries and everything so far. One of the more frequently used endpoints right here is to get a data set, and that also works quite well. I'm so familiar with that view, it's like, it feels like second nature in a way. That's pretty cool. So it works, it's a proof of concept, and we still need to refine that, of course, but in its core, it's working. We were reproducing everything that PyDataverse does and beyond, yeah? So going back to this more meta level of PyDataverse and its structure, this is kind of the updated figure. And we can see now that this low-level API is generated, yeah? And why this is so cool, I think, is that the effort of development does not have to go into this low-level API, maybe a bit, but we can now focus on other things, like providing more high-level concepts, focusing on UX for the developer at the end, yeah, like Julian talked about, and putting effort into that instead of these chores all the time. And also, of course, into testing, yeah? So we don't need that many resources right now and can save time and I think also money in a way, yeah? So with this generative approach, yeah, what are the pros? I mean, obviously, the coolest thing is that we have upstream control. So whenever Dataverse is changing something, it will be reflected onto PyDataverse. I think that's extremely cool, and it adds a layer of control also for the development team. Of course, what's also really nice is that it can be part of the CI/CD, so it can be completely automated. And last but not least, the cool thing is that there's support for any endpoint, yeah? So we have 345 instead of 36. Of course, there are also cons with that, yeah? And one of which is that we still need to implement tests by ourselves. And I mean, makes sense, you know, that's important. This is something where we partially need humans, but with the recent developments in AI, I think we can also make use of AI for that and provide robust tests with that. And of course, we need control of that. I wouldn't let it to generate it and just leave it like there, yeah? Maybe we need to have a PR system where we can do code reviews and check things. Of course, this is important. And last but not least, this is kind of what I see is the biggest challenge with this generative approach is how we can deal with different versions. Yeah, how can we provide backward support? That's still something that needs to be solved, but there are already things that we can do is like provide tags and tell like this endpoint is not available in 5.14. So we can implement something that checks and says, no, you can't use that. You have an old version, please update. Yeah. Now, coming back to the pros, and this is what I see in this project is the overarching pro actually, yeah? Because now we've used open API specifications to generate Python code, but we can go many other ways, yeah? With these two providers that I've used so far, we can go to TypeScript, Java, C#, Go, Ruby, C++, which my colleagues will love, Swift, Rust, and also R. This is extremely nice. We can now serve a bigger community with client libraries that makes it easier for them to interact with Dataverse at the end. And I've also included Swift because how cool would you think would it be if there's an iOS app for Dataverse or even on the iPad or something? I think that would be extremely cool. And with that, we are able to do that. So I think it's amazing, yeah? So we still have some to-dos to do. We need to progress on the open API specifications. We need to conceptualize the backward support. And of course, we have to do all the merging with the high-level APIs. But this is something, I guess, we're going to manage, yeah? And I want to use the time to also advertise for the PyDataverse working group meeting. We've had our meeting this morning, but to the bigger audience, I also want to advertise that we are completely open for you to contribute and work with us, not only to contribute code, but also contribute ideas and use cases. Because I think it's important to see where people want to go and what are the expectations of such a library so that we can implement that as a community. We have bi-weekly meetings. We have also a website on pi.gdcc.io where you can see the notes, upcoming dates, and also recordings. And we're extremely active on Zulip because Zulip is the best chat of all, I would say. And with that, I want to thank you all. Here's my contact address if you want to contact me. Otherwise, you find me on Zulip. And thank you for your attention.
All right, we are on to our next talk, and then we have one after this before we do our QA. So we now have processing of technical requirements gatherings for the integrative solution of the Fiocruz Research Data Repository, Arcadados, with the Research Electronic Data Capture RedCap tool. We have Luciana. I'm gonna call everybody who's on there to give them their credit. We have Luciana Monteiro Krebs, Maria de Fatima Martins Correa, Paulo Victor Cortez do Amaral, Jean Gabriel Nguema, close, Renee Faustino Gabriel Jr., and Vanessa de Arruda George. Jorge. George. It's all yours. Oh, okay, that's fine. I'll hold this.
Hi, thank you for the opportunity to be here, to hear and learn a lot with fantastic experiences. And I would like to begin introduce you my institution. Fiocruz, Oswaldo Cruz Foundation, is a public health institution of the Health Ministry of Brazil. We are a government institution with 125 years. We work with national and international cooperation. in research, education, and public engagement in science, for the science, technology, and innovation, for our unified health system, reducing inequalities in health, education, and science. We are in more than 10 states of Brazil, and we have more than 10 technical and scientific units just in Rio de Janeiro, where is the presidency. I'm from presidents of Fiocruz. I would like to talk about the ecosystem of the clinical research in the presidents of Fiocruz. The president carries out and sponsors clinical research for all that units. And the main platform, this is the main platform that makes up the clinical research ecosystem. REDCap, Arcadados, and another platform to biobanks. But I don't know if you know what's Arcadados. Arcadados is the name of our Dataverse installation. Is the official research data repository of Fiocruz. And these are our numbers. We have more than 35 research projects from different units in Fiocruz. We launched it in 2022, I think, the Arcadados. And these are our website. And I don't know if you know what's REDCap. REDCap is a research electronic data capture. Is a secret web-based application for building and managing servers and databases quickly and securely. It's developed by Vanderbilt University in 2004 and supported in part by the National Institutes of Health, NIH. They are used by multiple institutions worldwide in clinical research, and each institution installs and can customize its own instance of REDCap. Why do Fiocruz research use the REDCap? The clinical research area choose this software because the data capture software used to support and develop new discoveries in medicine and therapies and health technology. Use strategies to protect sensitive patient information. We have a lot of this type of information, while ensure compliance with privacy regulations. Produce reports with all collected data and or select instruments events. Also is able to create restricted reports, can isolate specific fields or metadata. Filters allow further additional customization, can restrict identifiable information, anonymization of the data, sports reports in multiple formats, and able to compare records between records IDs or events. Considering that REDCap has been adopted by Fiocruz president as the official software to clinical research data manage, there are needs to develop an automated integration solution to publish research data from REDCap in Arcadados. To enter REDCap data with Arcadados, the research follows a long journey that involves export the REDCap data, and they send or upload this data to Arcadados. These are all the steps the research has to complete in order to deposit their data today. And this work, the integration solution has three main objectives: to change the process of deposit of the data from a REDCap and make more user-friendly, to improve trust in the data chain of custody, and to make ingestions as 100% fair according to the Data Documentation Initiative, DDI, standards. What are the technical requirements necessary for developing the integration solutions between Dataverse and REDCap at Fiocruz? In the process of serving and documentation the technical requirements for the integration solutions between Dataverse and RedCap, we identified 8 needed. The multidisciplinary team with different professionals profiles, the structural model for technical requirements gathering, the institutional strategic objectives that the solution meets, the process of construction and negotiation technical requirements based on demand, user profilers should be authenticated in the system, the technical descriptions of the crosswalk, search cases of analogous solutions, and the suitability of the solution to the curation process and the institutional policies on open access and sharing and management of research data. I will talk about this policy in another presentation. The key advances include automate workflows and the greater visibility into the research and the data, accelerated the deposit of data in Arcadados, more efficient operation, low costs and time, and customized workflows standardization to meet demands. And what do you expect with this integration? No more multiple steps to deposit the data, a simple workflow to encourage researchers to share their data in Arcadados, like engagement strategies. These are in another slide, I talked about a lot of steps, and we think that we have just 6 with the integration. And where are we now? René and Fatima are working hard in this process, and we are in the proof of concept with the RedCap API. Would you like to have this button in RedCap to the research press and their data go to Arcadados? We have some conclusions. One is the filter available by the software by RedCap is available tool for the health research community as it implements security measures to protect sensitive information such as clinical and personal data of research participants. Another, this solution is potentially interesting for the Dataverse community, especially given the fact that RedCap is flexible enough to be applied in variety of research contexts, such as biomedical, human, and social research. And the integration between Dataverse and RedCap softwares can reduce errors and ensure data reliability when reusing data in different research because of the data chain custody. These are the tools and the support tastes that we are using in this process. And thank you for your attention.
The last presentation in this session. So we have using OpenID to support Dataverse integrations in a research commons environment. It's going to be presented by Jim Myers, and the co-authors are Sebastian Karcher, Nick Weber, and Sebastian Ostrowski.
All right, thanks. So I want to tell you this is kind of 2 stories. One is sort of, one is basically what cool things is QDR doing lately, but the other one is that what we're trying to do is really the same kind of thing you want to do in a research commons. So if you're interested in the other research commons things you've heard about, or you're a developer who's trying to think about how to integrate your application with Dataverse in a commons environment, these might be the things you'd want to do. Let's see. All right, so I skipped a slide. I'm too slow again. Let me go back. All right, it's not moving backwards. Oh, there we go. It's going to go. All right, so in terms of a research commons, you can say lots of things about them. You've heard about them before here. The things I want to focus on are basically that, you know, it's one way of integrating is basically to start having everything use everybody else's API and you tie things together. And this is not a research commons, right? When you have a research commons, you're really trying to do things by standards and not have that kind of tight coupling. So you really don't want to have to know Dataverse specifics to connect to other tools or vice versa, but you still want the seamless workflow between them. And so that's the challenge in this stuff. And that's really what makes these things extensible and scalable, that you can say, hey, I'm going to plug in a tool, and now I can plug in 3 different kinds of repositories, and if they're all using that same standard, I don't have to do new work for those new things. So that's really where the extensible and scalability comes from. And there are multiple aspects of that. So I'm mostly going to focus on the authentication stuff here. I have one slide just to point out there's a metadata aspect that we've been doing as well with some earlier work. All right, so the QDR context, the qualitative data repository that's at Syracuse, is working in this case with the National Institutes of Health in the US through this cross, NIH is multiple institutes, and this is a cross-institute thing that's helping to end long-term addiction long-term. So the opioid crisis, things like that, and all the different parts of NIH, there are studies across those that they're trying to share and then have people work on. And their idea of a platform, again, less block diagrammy here, but researchers are coming into the HEAL platform, finding data, and the idea is that that data may be at QDR or at Harvard or ICPSR or they've got like 20 other repositories where this data is going. And they want to be able to basically either download it from the HEAL platform, and you could download from multiple places at once, or actually launch it into a workspace. And I'll say a little bit more about the workspaces in a second, but basically into computation. Now, the one thing that was done at QDR with folks other than me mostly is putting together a metadata block and some transfer scripts. So HEAL has essentially its own vocabulary that it wants to be able to enable discovery on its side. We have some metadata, but we don't have all of it. So QDR put together a metadata block and then transfer scripts that can basically take our JSON and map it to their input format and vice versa. And I'm not expecting you to be able to read these things, but basically it's a big, you know, there are lots of things. It's like, what kind of population did you study? What kind of addiction things were you doing? What kind of treatment options were you doing? What kind of data is actually in there? So there's a lot of richness in their discovery environment that's supported by this metadata block. All right, so back into the authentication part in the workspaces, the idea of what they've got is, again, I'm not showing their main interface for search and discovery, but once you discover something, they have, here's your list of data sets and you can select some, but then they've got a little button that says open a workspace. And just like you were hearing from Stefano and you were hearing about the Dataverse NO Research Commons idea, that would launch you into, you know, a Jupyter notebook, a Stata notebook, whatever kind of computation that you've got out there in the cloud, and those data sets would get, those files would get loaded in. And so what we'd like to do is make that as seamless as possible. And so seamless in our case is basically that, one, you're using an Orchid or Google account to log into both, and so you essentially only have one login and password across both systems. We'd like it so that you have to do something to be able to tell HEAL that you're associated with QDR and you'd like to basically give access, but we don't want every time you want to download or find a file that you have to go log into QDR again. So we'd like you to kind of do that once, link to Dataverse, link to QDR, and then when you decide to go get stuff, even if it's restricted data, if you've got access to it in QDR, HEAL will be able to pull it over into the workspaces, and you won't have to go log in at that point. Which, although it's going farther than we're talking about right now, that also means that if HEAL wanted to schedule some jobs for you to run bigger computations, you don't have to be logged in when it's time to go get the data sets, because HEAL's got essentially your token to go work on your behalf when you're not logged in through a browser. All right. So in 2023, at the last DCM, I was reporting that basically the first switch we had to do here is to get to using OpenID Connect. So if you know Dataverse today, we support OpenID Connect, Shibboleth, local accounts, and so on. At QDR, we have a Drupal component where we've got some documentation in Dataverse, and so we put in Keycloak and basically have all our components talking OIDC, and we have our equivalent of local users in an LDAP repository, but those are basically our local accounts, or you can use your Google or Orchid login through that. And again, to keep kind of hammering this back to the community, with the single page application front end for Dataverse coming up, we're thinking that Dataverse is only going to support OIDC because it's the only kind of protocol that we can do that is secure for that kind of front-end application that lives in your browser. So you may see a similar setup when you get to that point, you may have the similar kind of thing, and you may have a Shibboleth talking to Keycloak on the far side to be able to keep your Shibboleth connection, something like that. All right, so that's what we did, and that basically allows us to have single sign-on. We can have local accounts, and now people can either have Google and Orchid log into the same account because the emails match, or when they log in with Google or Orchid, we create a new account and we do it just like you would do other places with Shibboleth and so on. So what that looks like, you click the login button. Now instead of a user password dialog in Dataverse, or in Dataverse software itself, it's Keycloak, but it's essentially a page pops up. You can log in with username, password, you click on Orchid or Google, and when you're done, you pop back into Dataverse, and there you are logged in. And with our single sign-in, essentially, if you do that same thing through Drupal, when you click from Drupal to Dataverse, you're already logged into Dataverse, right? Just the definition of single sign-on. So what we've done this year, which is new, is that allows you to single sign-on to us, but that really means you can log into Heal, then you can click on a Dataverse page and you can go log into Dataverse and you're using the same account. That's nice, but we'd really like that linking to QDR kind of button requires using another feature of OIDC, which is called offline tokens. And essentially, what that does, I'll show you a little bit more detail, but the basics again are just, when you say link to QDR, you're going to be redirected to our login page so you can log in. But when you log in, what Heal gets back is not just a short-term token that you can use today, but it gets a long-term token that it stores so that for the next 30 days, it doesn't have to come back. And the next time you do something in Heal, there you are, you're ready to go. That requires a couple things. Most of the development, I think, on this has been on the Heal side that they're working on. But basically, they're not doing something that's QDR or even Dataverse specific. They're just implementing the ability to work with OIDC offline tokens. So again, here's your nice Research Commons idea. They've done that. If you come into another application and you can support offline tokens, they're ready to roll. They can roll you right in. On our side, a lot of this was more configuration level. So Keycloak allows you to say turn on offline tokens, set them to 30 days. In Keycloak, we can find the endpoints and a shared secret that we have to give to Heal so that this is all supported. We've also turned on what's called token revocation, and I'll say more about that in the next slide, but it basically adds more security than just having a single long-lived token that might get stolen. And the last thing we had to do is, with the single-page application work that's going on for Dataverse, we're getting the ability to basically log in as an application and get your OIDC tokens, but to use that with the API, we've got another flag that right now is turned off in general, but you can turn it on so that the same token that you would use in the front end basically works with the API as well. So a lot of this, again, is but configuration once we found out by reading through the manuals which configuration things to turn on and off. And again, the slightly more detail on that is that when we click that button and we link and you log in, you get the access token, which is what you normally get and what you normally use, a user token, which basically gives extra metadata about here's the person, their email and their first and last name and their other information. And then you get this offline token, and that's the one you keep. And then when it's time to come talk to QDR again, All HEAL does is basically in the background says, here's the offline token. Can I get an access token right now that I can use? And then it can talk to our API. And in addition to getting the access token, it gets a new offline token. And what's fun with the mechanism where we're doing this refresh is that if you have that kind of offline token, right, if somebody were to steal it, these can only be used once. And so if they use it, as soon as you try to log in through HEAL, it's going to get flagged, and everything will you'll be locked out from that point. If somebody steals it and you log in through HEAL and there's a new token, that last token is invalid. So unless they use it immediately, it's going to be out of date. Even though we're going to allow the process to go on for 30 days, you have very short windows if there's active integration between these things, so that somebody could be malicious and do something. Yeah, and so again, the last one is just they can now, with the access token, HEAL can do whatever it needs to do on your behalf. So this is just diagrammatic the same thing. The point I want to make is basically the user is kind of going to the HEAL space. They're not logging in on a daily basis to QDR, but they're able to get stuff. And we really still are in access control, right? Whatever access restrictions and whether you've been granted access to files, all of that is still happening because you actually have a login token, and we either agree or deny based on that. This one, I wanted to kind of point out the difference between these kinds of things. The first column is what I've just been talking about, this new OIDC. The middle column, right, and everybody should go boo, is API tokens, right? We have them now, but as you can see, there's lots of red X's, so you should get away from them as fast as you can. They're useful, but they're not as secure as any other thing we've got. And the last one is the fun stuff of digital signed URLs, which we now support, and again, waving the flag. Our version 1.4 previewers now use signed URLs. They're much better than the early ones. Please upgrade to those as soon as you get to a compatible version of Dataverse. And the kinds of things that are different in here are basically, first one, the OIDC is standards-based. So again, for Research Commons, that's what you want. Second, because OIDC, because you have to share that initial secret, we've actually got a token that's limited to certain applications. So again, compared to the bad API key, right, if somebody gets that, it doesn't matter what application they use it with, they're you, right? And so you don't have the same kind of connection. Signed URLs have that same limitation. Once you have a hold of signed URL, you've got it, but those last for 5 minutes, right? So you get it, the app that's supposed to get it gets it, and then if somebody steals it, they've only got 5 minutes to do anything on your behalf. Secure automated delivery, again, you've heard me kind of walk through the flow that you click on a button, it goes to the login dialog, and at the end, the token is transferred. If you've got API keys or anything like that, either we have to launch you as an external tool where we can pass, that's the one automated way we've got of passing it. Otherwise, the user has to go find their API and API key and cut and paste it into the other application, because there's really there's no automated delivery or no automated way to get that between the systems. So again, that makes OIDC much better on public machines. Same thing with signed URLs. If you access Dataverse in the library, your API key, if it's on there, if somebody comes in after, if they can find that key, they're you. If you leave the library within 5 minutes, the signed URLs are done, and same thing, OIDC is short term. You can do more to kind of crank those durations up and down with OIDC and with our signed URLs. I mentioned already that how OIDC has this sort of one-time idea. So if somebody steals it, essentially, if you use the token before they do, that token they've got is useless. So that's a nice feature. And the last one, which is where our signed URLs are actually better than OIDC, sort of basically, is that with signed URLs, we can actually limit you to specific API calls. And so what's nice with the previewers is what we send, like if you're going to preview an image, the signed URL that you get is the one that allows you to read the data. You don't have access to the delete data set protocol, right? So if the previewer to view your data file were malicious, it can't call and delete your data or add new metadata or anything because we haven't granted it that permission. I think that's possible in OIDC, and I'm going to look at it. They've got some multiple levels of authentication kind of capabilities, so we might again be able to say, Heal's able to read this stuff, but we don't really want to grant Heal the ability to be writing new data into Dataverse. Maybe there are some cases we do, but in the scenario I just said, we might be able to limit them. All right, so again, kind of summing up, this is something that QDR, right, is involved in this HEAL project and involved with NIH. Harvard has other projects with NIH and is as part of HEAL, and so we're looking at this as something that's essentially a solution to that, but it's also something that in other research commons, right, this is really the more secure way than trying to do, and a more standards-based way than API keys or something else. It does use Keycloak, which again, since OIDC is coming, that might be something to get ahead and start getting Keycloak into your installations. And then if you have that, this is something that opens up for you, you can do. And again, to the developers in the room, this is another mechanism that gets you out of having to have users cut and paste their API key around, and it's more secure for the reasons I've said. So with that, I'll say thanks. I can tell you more about this stuff, but there are lots of other people in the room who know OIDC and Keycloak and things, so, you use your time here to ask questions about that. So thank you.
I'll do that. You guys are going to have a Q&A. I'm not carrying the chair. It's beyond my job requirement now. All right, so we have a panel of our speakers, so anyone who spoke after lunch. So we need 1, 2, 3, 4, I think 4 is 4. Yeah. Thank you. You too. Whoever wants to go. It's okay, whoever wants to. Yeah, you'll be fine. You'll be fine. Oh, well, Renee can chime in on the microphone. Do we have enough seats for everybody that was this morning? I think so. This afternoon, this afternoon. Okay, do we have any questions on Zoom? If we do, we can put it up. No questions on Zoom. All right, so it is all you guys. So we do have one question here.
Hi, thank you for your presentation. My question is for Victoria. And what type of algorithms are you seeing in each stage of the data curation tool?
What kind of algorithms?
What kind of algorithm, yes, related to machine learning, statistical, to clean or process data?
So it's using the DDI metadata standard, and in terms of statistical models, it's very simple. So it's generating like summary statistics, including means, that kind of thing. And then the cross tabulations are just based on a simple model that cross tabulate 2 or more variables and display the frequency counts, the cells within those. In terms of advanced statistical analysis, it doesn't currently support any kind of regression analysis, but that is definitely possible in the future, yeah.
Okay, thank you.
Any other questions on that side?
Hello? Oh, it's working. Great. Thanks, Jim, for the deep dive on OIDC. This is more just like a public services announcement that if you're a developer or you're interested in this OIDC stuff, it is part of our new containerized dev environment. So you get a Keycloak instance, and it's already configured to work with the Dataverse installation. You also spun up. You would just click OIDC, and we have a couple canned users like user, admin. So it might be a good way for people to start getting their hands dirty with Keycloak, and I agree with Jim that I think it's coming soon to a Dataverse near you, especially with the new front end. Thanks.
Any other questions?
Okay, I have a question about the RedCap work that you've been doing. the end result of it? Because I understood that it's still sort of in the concept phase. When it's done, will the code and everything that you've done for it be available in open source?
You ask if RedCap is open source? No, yes, her name Fatima, you register in GitHub, yes, René? He's not here, but he is the guy. So talking.
Yeah. The RedCap is open source, but you need associate with RedCap community. That is not free. Né? You need associate with RedCap.
So your adaption is part of the RedCap GitHub, or?
No GitHub is developed a group, the RedCap. Not open source in GitHub. You need download the source directly the community.
Yeah, the adaptation.
But it's free. You can.
René, ela está perguntando que como o RedCap não é open source, como é que a gente está mexendo no RedCap? Não,
nós somos da comunidade. Como é que se fala?
We are part of the community of RedCap.
Nós somos da comunidade.
And we can use your codes, and we can.
We can development train. We can modify the code and submit to available to RedCap.
The community, to RedCap community.
Oh, so we can find it there. Okay, thank you.
For the Oswaldo Cruz Foundation, I wanted to ask about the 8 different needs you identified. Which one do you think is either the kind of base for the other ones, or like the most hard to even kind of conceptualize a solution for?
I'm just the business manager, and they are the guys that's working this. Quais daqueles 8 passos foram os mais difíceis para vocês fazerem? Das outras 8 necessidades.
Na realidade, o último passo, que juntar tudo num único pacote.
It's more difficult the last one, that we have to mix everything in the same. And create the DDI metadata. This is the hard step for us.
So the standardization.
Yes, the standardization with DDI, yes.
I have a question for Jan. Any plans to extend PyDataverse with data frame support? I really believe that it will speed up adoption of PyDataverse.
That sounds like a really good addition, of course, yeah. So we can certainly do that. I mean, since these metadata blocks are kind of only 2-level, this is easier possible than in any other structured data format. Indeed, that would be nice, yeah.
Yeah,
definitely.
So the idea, if you'll put in Jupyter Notebook PyDataverse and just quickly get all stuff in pandas data frame, I think this is what researchers want.
I agree. I think I would use it too, for machine learning and all data analysis stuff. I think this is quite handy to have, definitely.
Okay, so it's on roadmap.
Of course, yeah. A bit later though, but it will come.
Any further questions? Okay, I think we are actually scheduled for a break, but just so you know, the technical overview and front-end developer's guide to the new Dataverse architecture is happening in room 11, which is in here. I'm sorry, room 10, not 11. TR 10 is just the hallway here. If you'd like to attend that, that's happening in parallel. So we have a coffee break, and we will start promptly at relax before the soccer tournament. Everybody come on back in. And we had turned the AC to make it a little cooler, and we'll turn it off in a second so that people don't freeze. Thank you. Because I don't want to lose the time we saved. This doesn't work out here, does it? All righty, I'm closing this door here. Everybody go in the other way. Tech, he's going. All right, we're going to start so we can maintain the time we've saved today. All right. So, is everybody here, first of all? Okay, hopefully everybody's already here. Because this last session today, we have we have 4 presentations before we end and move on to a little rest in Dataverse Cup. So we have the People Development Project, PDP of the Fiocruz Open Science Ecosystem, implications and strategies used to promote open science through corporate education. Come on up. Vanessa. You can use that.
Let's go again. Sorry. Working. I talked about Fiocruz in the last presentation. Then I will not talk again, but I will focus in our role in open science issues. Fiocruz has been developing several practices and actions to strengthen the research data sharing movement, open data movement, based on open science ecosystem. We work all these things together with some strategies like with policies, guidelines, and governance, initiatives and platforms, networks and partnerships, and education. Fiocruz has 2 policies and 1 guideline officially approved by the Deliberative Council and many initiatives in other areas of open science, such as projects in citizen science, projects with the notebooks, labs, electronic labs. But our first policy was open access policy in 2014. After this, we approved 1 guideline to open educational research in 2019. And the last one was the policy about management, sharing, and open of research data in the middle of the pandemic, on a critical moment of the humanity. About the Fiocruz Open Science governance, we have a structure to conduce this STEM in Fiocruz. We have an Open Science Forum that this forum is responsible to make the strategies and align these things in Fiocruz. We have an ARCA steering committee. ARCA is not our institutional repository. We have the ARCA Dados, the name of our Dataverse installation, steering committee. We have open science centers in different units that in the Fiocruz. More than 20 open science centers in our institutions. All these profiles participate of this governance in Fiocruz research is the group of research integrity, the group of research ethics, the group of best practices in research, the quality in research, the group of technology management and innovation in research, the group of the scientific dissemination, the group of digital preservation, information access right, library network, records management, scientific editors, the group of education. We have more than 48 post-graduation course in field programs in Fiocruz. The clinical research in biobank, I talked about them in the last presentation. Information technology and all our regional units. We have some initiatives and platform softwares that composed this ecosystem. I have some of them here. Dataverse, and our Arcadados, the name of Dataverse, our data repository for research. The ARCA, our institutional repository in DataSpace. Our Educari, our open educational research software. We have 9 open access scientific journals in Fiocruz, in OJS. We have an observatory in science, technology, and innovation in health that gives transparency about our metrics and our indicators and our data. This initiative talked about our metrics in Fiocruz. We have the field, the MP, our system to develop data management plan. And we have another platform called Porto Libre. Porto Libre, eu não sei se em espanhol é assim. Porto Libre is a platform to open books. We composed some networks and partnership too. We've participated in and contributed to groups on open government. We are a government institutions. In global health, the Global Health Network, in reproducibility, we are part of Brazilian Reproducibility Network, a network from repositories, and the national chapters of the Welfare Health and the RDA in Brazil. Our strategy of education, open science education, is composed by three strategies for different groups. One is the modular training program in open science, a MOOC. We have more than 25,000 subscribers in this MOOC. It's open to anyone interested. We have another strategy, a cross-disciplinary course called the Introduction to Open Science, just to students from our postgraduate programs. We have more than 250 students since 2021. The new one is the People Development Program to Open Science or Ecosystem, PDP. Started in the end of 2023, is for our employees, Fiocruz employees. We would like to engage them in this movement. The PDP is a capacity building program, is an initiative to develop the competence, knowledge, and skills required by open science for its works. The idea is that the professionals will be able to promote and monitor actions to implement open science, make scientific data and information available to society, as well as encouraging the management sharing and opening up of research process with the participation of citizens, because we would like to talk about a citizen science. Our general objectives in this PDP is engaging in develop 200 professionals from our 21 open science centers. Reflect on and implement open science action in them units. We are in all Brazilian territory. I showed this in the last presentation. And our target audience to train is research, the people involved with vice director for research and the research advisors. Education, the people involved with the vice directors of education and or postgraduate coordinations and the academic secretariat. Information, units, reference libraries, the units document management services or centers, and the IT group. Technological Innovation Center, our NIT, NIT, the group of lawyers that we have in Fiocruz. Units that have a scientific journal. I said that we have 9 scientific journals in Fiocruz, and the units that have one scientific journal is part of this Open Science Center. Research Ethics Committee, the people who works with the ethics in our institutions, and the curator of Arcadados. We would like to train people to be a curator in Arcadados. Today, centralized, we have a curation centralized, but we would like to go to a decentralized curator in our institutional repository. So it's not a course, it's a question that we always received. It's not a single solution with a specific date and time. We offer continuous asynchronous and synchronous activities according to the proposed learning objectives. The participant is the protagonist of their development, learning according to their available time, interest, and learning needs. It's so flexible. PDP and its learning pathways. We launched the introduction to open science on last September 2023, and we will launch OpenX in April now, in 2024. Open education and data management sharing open, I think, in August. And we are launched all these pathways in our institutions. The pathway contents of data management, sharing, and opening involves concepts of good practice, principle in data management, ethical and legal aspects for the data use. We are a health institution. We have a lot of problems with this type of issues. Data management plan. We will prepare the people to preparation of data management plan. And Acrodados, our Dataverse. We preparation the people in our operation documents. We have a lot of operation documents in Dataverse, more than 7, Fatima? More than 7 operation documents. We will prepare them to train other people to deposit the data, and the curation, the process of curation, to decentralize one time, other time in Fiocruz. These are the education resource and expectation on data management sharing open pathway. We think we improve skills, virtual communities, lesson learned, exchange experience, teamwork, workflows. They have access to academic articles, data share agreements, audiovisual research, and other things in this program. This is the screen that they have access, our virtual learning environment made available to Fiocruz Works all of them can log in this area, in this virtual platform, and they could do the program in this environment. Then, to conclusion, Fiocruz has a history of actions to improve its professionals, to fill the gaps in training actions, not just in open science, but now we talked about open science. Understands that professionals are agents of social transformation, responsible for the process of construction and reconstruction of their realities, based on the context in which they are inserted. This model can be reproduced in other institutions, and we will be happy to contribute to this. Thank you.
A question before we go to the next presentation for you, because I know that you guys have a lot of Dataverse. I know you guys have a lot of Dataverse installations because I know your community. But how does Fiocruz, with all of the objectives you have here, how are you guys now working with Carignana, EBECT? What is that relationship now?
We are part from these networks. Our Carignana, EBECT, we are pilot. We went the first pilot from EBECT to implement a data repository in Brazil. We are the first. Then René is working with us in these networks. And
Please do. Thank you. Thank you.
And René is with us since, why we are part of this network.
Right. Okay, thank you. All right, next we have Juarez. And we are going to be Juarez Henry, Advancing Disease Management in Potatoes Through Fair Data Integration and Digital Technology Applications and QA.
Thank you, Sonia, for the introduction. My name is Henry Juarez. I work at the International Potato Center. And I'm happy to be in this Dataverse community. I'm learning a lot. So many things I'm going to take it to my institution. What I'm going to do is to talk a little bit about the potential of digital technology and how fair data principles and how they can improve our capacity to address agricultural challenges. So at the end of the presentation, I want to answer a question of a farmer that asked for help about his or her potato crop. So this is what I want to present this afternoon. So SIP is one of the 15 centers. Our headquarters are in Lima. And our objectives are, this is our programmatic science goal. We have biodiversity, crop improvement, regenerative agriculture, and also urban food systems. So this is the new strategic plan we have for 2030. And this is what we are going to be focused on the next 7 years. For biodiversity, well, mobilizing genetic diversity to enrich agroecologies and livelihoods. For crop improvement, developing superior varieties that meet the climate and also the challenge in the future. In regenerative agriculture, enhancing farm productivity and ecosystem health with our roots and tuber crops. And we have a new science goal that is urban food system that no other center is taking into account. So this is a new pillar in our strategy. So this is our science goals, and this is how we manage our data in our center. So what we did is to connect the project life cycle. So all projects are similar. to connect with the data life cycle. So in the project life cycle, they start with the grant, they start with the writing proposal and so on. And in that place, we start with what we have with the research protocols we have, so the standardization of the vocabularies, ontologies, and so on. We start with also with a data management plan. That means that all projects has the potential data sets that can contribute to the center, to the open data science. Budgeting and planning is also important to allocate resources for data management. And this is the life cycle. And we also have documentation, data quality, data storage, and archiving in our repositories, privacy and confidentiality, that is important. And finally, the data repositories for the open data, open science. And at the end, we do a checklist for the data management plan to ensure that all data sets that were in the data management plan at the beginning is finally at the repositories. So this is a workflow just for breeding. We have workflows like this for breeding biodiversity. And everything starts with a protocol. So this is the life cycle again, the data life cycle. And we have a protocol for yield, late blight, dormancy, and so on. And we have some tools that contribute when we create the data or when we process, analyze the data. Now we have like HideUp, Agraphims, FieldWorkup, and we use crop ontology at the back. For data storage, we preserve our data sets in potato and sweet potato base, are the basis for these two crops, for potato and sweet potato. And we use Dataverse as the repository at the end of to make it open at the end of this cycle. So this is our repository. We have a local installation in Amazon. And what we did is we started in 2015 with one data set that was mined to try to motivate researchers to open their data. So, but at this point, we have 750 data sets. So it's a good achievement in the last 7 years. There are more than 5,000 files, individual files, and there is almost 28,000 downloads of our data sets. So this was very important for our center because, as I show in the workflows, we have biodiversity, very good workflows for biodiversity, for crop improvement, for the social sciences, not for the regenerative agriculture, not, and also for the new pillar that we have for urban food systems we don't have. So Dataverse is a great tool to have all the data that we are producing in the center, and also making it open. So we went from an organization more open, but this is important, this part, the concept of findable, accessible, interoperable, and reusable, because open is not everything we need. We need that more than findable and accessible. Now it needs to be interoperable. So I'm going to share one of our legacy data sets that we have. So in this data set, when you look at it, you have documentation of the data set inside the data set, some columns that has some names that I can understand, but all are different. When I combine several data sets together, it's not possible to do that. To solve this, we use control vocabularies like this. So we have NTP, MPH, and so on for each of the variables that are standardized for all for the crop. So NTP means number of tuber planted. MTGA markable tuber gene adjusted, and so on. With that, we have the ontologies, and we have ontologized this data set. And at the end, we can combine all the data sets together. This is for legacy data. For the new data sets, we are doing our best to have, not to have this, sorry for that, but to have something like this. So again, the point here is not only open, but also interoperable. So that's with data variables that describes very well what we are measuring in the field, using these standards like ontologies, like common data dictionaries, and so on. So we also have some tools. This comes from Excellence in Agronomy. For legacy data, we have FairScribe. It helps a lot to document the metadata and also to rename the columns of the dataset. We have Carob. Carob is a tool that helps to aggregate different datasets, so to combine 100, 200 datasets into one simple large collection. And to make the data born fair at the beginning, there are some tools like HiDAP that I showed before in the workflow for breeding, agrofins, DataScribe, and so on. So there are several tools that can help us to improve our data documentation, data dictionary, ontologies, aggregate the data, and document the metadata with these tools. The idea is to create a data pool that can help us to analyze this ready data or use modeling or decision support toolkits to answer questions in agriculture or in any other domain that we are working on. For example, fertilizer, planting date, variety, pesticide application, and so on. So here is the question at the beginning of my presentation. And the question is very simple. The question is hey SIP, well, SIP is International Potato Center, well, that means that Centro Internacional de la Papa. Hey SIP just need to know when is the right time to spray and beat this potato disease. And it looks very simple, but it's very difficult to answer. And the why is because we have the disease for many, many years. This is caused by this pathogen. It's extremely efficient. It has 5 days life cycle. It has an X rate for 100,000. Can travel 30 kilometers from the field. And it can destroy a crop or the potato crop in 7 to 10 days if it is not managed well. So late blight occurs everywhere. So late blight we have in all the world that has this cool temperature and high humidity. So the disease is very high. And as a bad example, the Irish potato famine in 1945, died 1.5 million people, and another million has to emigrate just for this disease because there was nothing else to eat. And this is happening now, 2024. Again, we still have 10 billion losses by this disease in the developing world. So this is the disease. This is and can destroy the crop very, very, very soon. So to combine all this information and try to transform data into something useful for the farmer, first is the variety resistance. So all potatoes has different levels of resistance, so we have that data. Weather data is important. So the idea is to have daily data of temperature, relative humidity, and rainfall, and also to have a forecast for the next 10 or 15 days so the farmer knows what's going to happen in the next 2 weeks. And decision rules that comes from the aggregated data sets. So every time we add a data set here, that is ontologized, that is very well described, we can improve these decision rules for the farmer. So this is the prototype. It's a prototype. The farmer only needs to locate his or her plot, indicate the planting date, and forecast for the next 15 days what's going to happen with the crop. And also the name of the variety. No? So we have a database behind that shows what level of resistance of that variety is. And then we combine the weather data at this place, the resistance of the variety, and the periods of time of that location. And we can give some recommendation like this: spray or not spray in yellow the fungicides for that crop. So this is very useful because this is the disease, for example. 100 means that the plant is killed, so it's dead, 100% of disease, and this means that it's very healthy. And with the decisions rules that I have presented, we could control very well, and also could reduce 20% of the fungicide use in a susceptible variety, and almost 30% of the fungicide use in a moderate variety. So that's important, how we connect data with the one question that a farmer has. So as I have this in one location, I can do spatially also, and have these risk maps for a country, for a region, where the disease pressure is higher than in any place. So this means number of sprays. So in this place, we need to have more than 15 sprays to control late blight in a susceptible variety, or 10 to 12 sprays in a resistant variety. So this is how we combine all the data sets at the end to respond a simple question: help me with my potato crop. So my final thoughts about this is that we are moving from the open data, and we need to be more accessible, but also interoperable. It's important to have well-standardized data sets. So all the tools we are discussing in this conference are changing the landscape of data collection, analysis, and sharing. So there is a lot of potential to use all this information. And also the potential of digital technology and these fair data principles in agriculture goes well beyond late blight in this example. So the integration of, for example, AI, machine learning, and can help us to address these challenges in the agriculture sector, and also in many, many cases in real time. So that's all from my presentation, but I would like to also share with you that we, last Friday, we launched the AI Agriculture Challenge. So it's a hackathon. It started in March 1st, and you all are welcome. And if you can share also this with your colleagues and universities, it will help us to make a global impact to solve some problems in agriculture. So, thank you.
I will share. Thank you very much.
Thank you so much.
Any questions? Okay, great, thank you. That was really informative. All right. Give me 1 second. Thank you. Okay. I believe we are on. The next presentation is Educational Data Mobilization to Promote Research, the Case of the IFE Data Hub. Hector Ceballos, Joanna Alvarado Uribe, and Paula Gabriel Mieja Almada.
Hello. Yeah, thank you. Hello, everyone. I'm so glad you could join us today. We are talking about our strategy to mobilize data in order to promote the research and educational innovation. We are Data Hub from the Institute for the Future of Education at Tecnológico de Monterrey. IFE is constituted of 8 initiatives that address key challenges related to improve the learning in higher education and lifelong learning, such as skills development for the industry and its workforce, attraction and engagement in teaching and learning, and convenient and affordable education, and so on. Specifically, from the IFE Data Hub, we promote database educational research using statistical algorithms and artificial intelligence algorithms by providing access to institutional data collections to members, professors, researchers of Tecnológico de Monterrey, as well as external and international researchers in collaboration with our researchers. We generate value for educational institutions and stakeholders interested in development of projects that encourage the creation of models applied to improve education and its process. To achieve this purpose, we offer 4 services. The first is the generation of data collections, from which we design and management of data-driven calls for proposals. And this process is a management of within the Tecnológico de Monterrey Research Data Hub platform based on Dataverse. And more recent service is related to the consulting on projects focused on educational issues, for example, in the data modeling and the generation of models to resolve educational issues. To mobilize the data that we integrate and curate, we have established 2 means. The first is on the request, and the second is through our calls for proposals. To do this, we have following a data mobilization methodology very similar to the proposed by Cantillon et al., which consists of 5 stages. The first stage is when we have access to the primary data of the departments, and to subsequently transform them, this data and harmonize and clean data. Based on this harmonized and clean data, we generate curated data set focused on educational challenge. This construction is supported by experts researchers in the area for achieve the 5 stages, which are related to the use this case specific data set. And we have two means to sharing and reuse of this data set. The first is the data-driven calls for proposal, and the second is a data descriptor where derive of these proposals. Our first service allows generate data collections, validate specialists from the institution in order to count on anonymized, updated, and documented data. Okay, I think. As a result of this process, we have 18 collections available upon request, and another collections in progress, counting on more than 700 variables integrated so far. Based on these data collections, we design and launch data-driven calls for proposals, which are academical powered projects by the Tecnológico de Monterrey departments that seek to carry out further research, analysis, and development with their data. This second service follows a process that involves from the definition of the scientific challenge such as academic dropout, the analysis of our competencies, and secondly, the integration of the data set which are constructed with the support of the expert groups who collaborate in the design of the call and the case-specific data set, and to continue to a research process based on the data set provided in our call. Both services generate data and documentation which can be consulted through the Research Data Hub platform.
Okay, so now I'm going to explain more deeply what I explained in the morning. So we have like two different types of data. One is the data that is generated from collections, as I mentioned before. That is institutional data provided by many departments from Tecnológico de Monterrey. And we also developed, as Joanna said, specific data sets that are given to researchers on the call for proposals that we manage. And the other process is the request and deposit and download of data. So here is the steps that are followed. Now, our institutional data, as Joanna mentioned, is more like taken into account as sensitive data because it's institutional. So we follow a process. For example, we ask a researcher all the information, like his source, where the affiliation, the LinkedIn page, because we have to know that it is a real person and it is a researcher. So we don't give data to other person that is not affiliated to some university. So after that, we gave the data dictionary so they can see what variables do we count on every collection. And after that, the researcher fills this information. He also can like ask us only certain variables. So the data set is very specific for the needs of each researcher. Then we do the validation of that request. And after that, we need to give him, following our data governance statements, we need to have some terms of use signed by each researcher and by each participant that has access to our data sets. And then after we validate all of that steps, we can send them the requested data sets. So our numeralia, we have 43 requests of our collections and our specific data sets, 81 researchers from all over the world, from 18 countries. So here are the results, changing how do we increase over time our use of the data. For example, in 2022, the Dataverse requests were 18, and in the calls for proposals were 12. That was a student dropout call for proposals. And our data descriptor, we have a request with our data descriptor for researchers, but in 2023, we can see that our data descriptor has given us more visibility. So researchers from India, from Pakistan, from a lot of places have access to our data set. And in 2024, we are starting to give more awareness of our new collection, so we are starting that process. And here are the calls for proposals that we mentioned that we generate, our curated data sets. The first one was an internal collaboration with Analytics and Business Intelligence Department from Tec de Monterrey. The number of participants were 11 teams with 31 researchers in total. And the results were one data descriptor that the department, Joanna and I developed, and 7 articles from the researchers. The second call was called Analysis of Competency-Based Higher Education. And this also was an internal collaboration with the Innovation in Education Technology. The teams were 18 and the researchers, we can see that incremented in 2022 to 61. So now the resulting articles were 1 and 2 in press. We can see this difference because the student dropout data set was of 143,000 registers, but the competency-based were like 1 million registers. So sometimes it is difficult to get the analysis of that amount of data. The third call was analysis of higher education student profiles with social commitment. That was launched in November of 2023 with 13 teams and 43 researchers. And they are in the part of analysis, so we are waiting now for the resulting articles. So the conclusions, to mention, our Dataverse repository began with this initiative of the IFE Data Hub because we wanted to solve like educational problems. That's how we get to make this repository so we can follow the FAIR principles. Our data mobilization strategy has allowed us to generate call for proposals through data collections, promoting educational innovation, and encouraging scientific publications based on these curated data sets. Furthermore, the publication of a data descriptor on these data sets has contributed to sharing this data, resulting in a total of 34 requests in 2022, increasing to 51 in 2023. So finally, based on these requests, 9 research articles have been published in journals of those quartiles and indexed in conferences. So we demonstrate the success of our initiative after 2 years of being launched. So I think that's the importance of how we not only create the data sets, but we also make calls and we also generate a data descriptor so we have a more visibility in other countries. So here is our team. If you want to contact us, Joanna is the responsible for data-driven calls, and I am the data operations and coordinator. Thank you. Thank you for your attention.
Hi, thank you for your talk. So you're releasing the institutional data to drive educational research at your institution, but also broadly. Yeah, this is so interesting. How did it get started? Was there an ask, like a need at your institution for hosting that kind of data? How did you convince the administration to release this data?
Right now, our institutional data is more accessible through request. So our Dataverse, our branch, our Institute for the Future of Education, is more like controlled because it is institutional data. But we also have, that is the private collections, and we have the educational innovation collections where researchers, for example, from the School of Innovational Education, from Social Sciences and other branches, can add and deposit their data. So the idea is that the researchers that deposit their data is available fully in this repository, but right now we are delivering this data by our own means, for example, because of that, all the restrictions when you have sensitive data, alumni data, campuses, all of that information. So that is the value of us is that we validate all of this data before giving it to the researcher. But right now they are not existing there. So it's not openly available. But the idea is that, for example, we have other schools, other institutions, and the educational innovation collection where that data exists there in the repository. So now we are managing that kind of, yeah.
Wonderful, thank you.
Thank you.
Okay, on to our final presentation of today. Open source tools to enhance data collection and management for plant science research. Luis Vargas Rojas. Welcome.
Hello, everyone. My name is Luis, and I am a PhD student in the agronomy department at Purdue University. For my research, I collected data in a wheat experiment that is located in the research facilities that CIMMYT has in northwestern Mexico. And I also collected data from a soybean experiment that is located in the research facilities that Purdue has in the US. So today I will talk about two tools that we developed while I was collecting data. The idea of this tool is to enhance some of the steps for collection and data processing before we can share them in data repositories. And these tools work for research on plant science. So I will start talking about what is the traditional data workflow on this plant science research, and then I will talk about the challenges that researchers have when they are collecting data and processing data, and then I will describe the two tools that we developed. At the end, I will share some of the results that we found after testing these tools in different experiments. So I will start talking about the traditional data workflow that I found when I start collecting data in these two research labs. So data collection in plant science can be divided into three categories. The first one is data that are collected using paper field form. So paper is still used on data collection for plant science. The second group is data that is collected using some devices, like some scientific instruments that have their own memory for saving the data that are collected. And the third group is data that is collected using remote and proximal sensing techniques. So usually, after the data is collected, the data is transferred into Excel files where they have different formats, different structures, and each variable is stored in either different files or different columns. Then the researcher makes a data quality process where outliers are corrected, and then the files are saved, usually in, into some directories that have many nested folders. So the problem is that when the researchers want to use this data to make data analysis, they spend time trying to find the correct files. Then when they find the files, they have to join and convert into a similar structure or similar format. As we can see, plant science research has many challenges to bring the data into a repository. So there are many previous steps that researchers have to do. And the other problem is that for small research labs or graduate students, they cannot afford the available tools that already exist for make this process better. Because the lack of budget, or because the lack of infrastructure, or because the lack of staff that has these IT skills. That is why we decide to develop these tools that are open source and that they don't need for the user to have these programming skills, or there is no need for infrastructure. So here is the first tool that is called ACTDC, that comes from agronomic template creator. The objective of this tool is to create a template that has the same format in order to the researchers collect the data into a standard format. So it is very easy to use. The user only have to enter the instructions of how the template should be created on text in a configuration file. So the user only run this line of code and the template is created. So the template has all the information that the user has indicated in the configuration file. And usually, all this information allows to identify which sample belongs to which plot. And this template also creates a row for each measurement that we made in the same experimental unit. For instance, in the same plot, or in the same pod, or in the same plant. But more importantly is that it creates an ID of the sample, and this ID is human readable. So once we have created the template, we can open it using a mobile device directly in a tablet or cell phone. But also there is a very famous and wonderful app for collecting data in plant science research that is called Fieldbook app. So we can use this template to open as field for this Fieldbook app. So the Fieldbook app requires for the user to upload a field. So this makes easier to collect data when we are in the field. So we are replacing data collection in paper. And the template also can be opened in a computer that is much better when we are processing samples in a lab. So we are enhancing the way that we collect data, but after data is collected, we have multiple files that were collected using either the template creator or that were collected using other devices that have their own memory for save the data. So we have multiple files. So before to analyze or share the data, we have to join all the files into a standard data frame that will make us to automatize many processes such as data analysis or data sharing. So these steps, the second tool is called ETL that came from agronomic data extraction, transformation, and load. The first two steps are extraction and transformation, where files that are where multiple files are extracted and joined in the same file. And then the user can transform the data. Here is where the user can use ontologies or controlled vocabularies in order to standardize the names of the columns, etc. Again, it is very easy to use because the only thing that the user needs to do is to enter the instructions in a text file. Here is an example of how ETL works. In this example, we have different files that came from collecting data into different traits. For instance, plant height and leaf area index. So these files share some columns, but also they have some columns that are different. So we join them, and we find that the measurements were saved in different columns. So we still cannot automatize the process of data analysis. So here is where the transformation processes standardize the file, where all the columns that have measurement units are transferred into the same column. And also, we are able to update some of the elements in the table. Now we have the data in a standard format, in a single file or in a single table. We already can analyze the data. We can share the data, but if we want to preserve the data, we need to load them into a database. So the load step makes or helps to the user to load the data in a friendly way. So the user doesn't need to have database knowledge in order to make the database connection or creating the tables. So just by text, the user can create all these tasks. Here I am sharing the results that we found after testing these tools into different field experiments. So we tested this in a soybean and wheat experiments that were in the field. And so IQSS was able to create templates for collecting data from these experiments. But also we tested the templates created with IQSS on a rice experiment under controlled conditions, let's say on a greenhouse or in a growth chamber. So additionally, IQSS was able to create templates for collecting data of samples that we process in a lab. While AgETL was able to process all the data that we collect using IQSS or also data that we collect using other scientific instruments. So at the end, we've had a database that where all the data are in a single table. IQSS and AgETL are open source tools, so they have an open source license. And in their GitHub repositories, there is documentation in English and in Spanish in order to make the users, they can use it more efficiently. And there is also some tutorial videos in that repository. And recently, we published a paper where we describe the tools that we develop and the results after testing these tools. So it is you can check this paper too. In summary, IQSS and AgETL can help us to enhance some of the steps in plant science research. While IQSS creates templates to improve the data collection process, AgETL helps us to reduce time on the data processing steps. And also, AgETL helps us to upload the data into a database in a friendly way. We are currently working with a research group at Purdue University that is working with or developing a remote sensing data management open source online platform. So they are going to use these tools for the data that they collect as ground reference. So they are working with remote sensing data, but they still need to collect data on the field to prove the models that they develop. And this group is also developing an user interface to integrate or to make more easy for the user to create the templates and to run the ETL process. Thank you for your attention. I will be happy to answer any question that you have. Thank you.
Okay, everyone. We are done early, which is awesome. Always awesome. So, you get some time to relax. The soccer game is at 5 o'clock. The field is in front of the cafeteria. They were putting new lines in there today, so Gustavo doesn't cheat. They were cleaning it up. So, we encourage you to play. Come and join us, everyone. Rory.
They have nets. They have nets.
Oh, they have nets too. So he really can't cheat this time. Okay. So, and then we will see those of you who are joining the 10th anniversary celebration at 7 p.m. tonight at the room where we've been reusing all of the celebrations and having lunch. Say the name one more time. Rincón Mexicano. I'll remember that like 3 weeks from now when I go back to Boston. Thank you, everyone. Enjoy your time. We'll see you tomorrow morning, tonight and tomorrow morning.